What is up, everyone? We are back again today, day 2 of the Data Innovation Summit 2023. I hope you had a good evening yesterday. We certainly had. I don't know if you can tell by my voice, but I was trying to scream louder than the speakers here, and well, I can tell you it's not possible. In any case, I had a lot of good conversations with people here, was hanging out with the exhibitors, with the attendees. It's really neat because these stages have been so well organized that people are hanging out at certain stages and feeling like they're really able to hone in on the specializations that they've chosen, whether it's machine learning, analytics, business management, all that kind of stuff. So glad to see that. Today is going to be a bit more of a focus on applied machine learning and applying all the principles that we've been talking about here. There's going to be a lot of product demos here on this stage. In the Octagon, we're going to be seeing demos from Keboola, demos from IBM, the demos from SqlDBM, everything M. And we're going to have 2 panels here today during the day. And we're also going to have out on the floor demos that you can try hands-on. I'm going to be demoing GPU acceleration and GPU programming and how to squeeze out every last ounce of performance from your CPU. There's a machine over there in the corner in the HP booth that has 150 cores in it, and I'm going to show you how to program so that you can actually use all 150 cores at the same time. It's not as easy as you think. In fact, some of these machines are really hard to load maximally, to use the disk maximally, to use the network card maximally, so I'll be showing some of that. And I think the demos that we're going to be seeing out here today are going to be really, really cool. So I think in summary, one of the neat things about the division that we have here today is that, you know, day 1, you hear a lot of the terms over and over again, although I think this year we've been hearing more entrepreneurial concepts being floated around. We've always spoken about value, but this year people have actually been asking, what do you mean by value? How do you measure value? Are we actually talking about the same thing? The thing that I think the customer values might not be the same thing the company values, and so forth. So nevertheless, I think the discussions that we've been having this past day have been super valuable. And today is the day when we need to apply a lot of those principles, at least for the technical-minded folk. And for the business-minded folk, I'm hoping that you can keep your energy up, all the energy that you got in yesterday's events and all the energy that you're going to get in today's events, and transfer it to your organizations. So with that said, I think we're going to open day 2 of Data Innovation Summit 2023, and I'll be seeing you shortly. We're going to have a couple of keynotes here on the main stage, so stay tuned for those. They're going to be really sweet. We're going to have Henrik opening, and then a couple of new speakers that you don't want to miss. So stay tuned, and I'll see you soon.
Good morning! I'm gonna blame the meetups we all had in our booth at the demos during the technology in practice sessions when you listen to my voice. That's what I'm gonna blame. Let's not talk more about that. Great day yesterday, kicking off the second day. Let's see if we even more people here today. We don't know. The theme for the conference, Data Innovation Summit, is from data and AI transformation to decentralized data and AI value creation. Yesterday, we boiled it down to adoption is the quantum of innovation and value creation. Today, we're going to unpack decentralized, why we put that on the theme this year. Let's start with a bold statement. Decentralization is a survival tactic for a future in motion. Is that true? What do I mean? If we look at centralization, it's great for scalable ops, but it doesn't give as much market agility. It becomes rigid, it becomes stale. It suited us well when our productivity frontier was slower in moving forward. We could build an ERP system and we wanted to have it for 10 years at least. Then we can build systems in one way. On the other hand, on the other end of this scale, we have unstructured adhocracy. We have an organization, we have a way to build systems where we do everything as point solutions. Here we have extreme market agility, but it's not scalable at all. It's in this context where I want to frame decentralization and really more talk about decentralized federation as, trying to eat the cake and have the cake. So how can we go with the intention of both market agility and scalable ops? Decentralized federation. So decentralization, sometimes you see this as central versus decentralized, the bipolars. No. It's the middle ground we're going for here. And the challenge is, of course, is to avoid exponential coordination costs as we scale. Typically what happens though, when we start doing things, we kind of fail to get this decentralization working, and in effect, we have devolved into unstructured adhocracy. The typical large enterprise today has a couple of big monoliths, and then they have point solutions all the way down to Excel. So we're living in hell from both ends. We have no scalability, and we have no agility. If we get it wrong. So let's go into this. I want to dive into this topic. What are the key mechanisms that makes decentralization work? I'm not going to go so much into the core federative part. I'm going to go into the fundamental idea of product thinking and product first ways of working. So product thinking, I'm going to frame it quite narrowly now on the stage here today to make a point. So a product is a composable and reusable interface between a provider and a market. So you're doing something that you want more than one to be able to use. Many years ago in a different lives, I had the opportunity to work when Ericsson introduced product lifecycle management. So they had from many years, 30, 40 years working in a project cycle, how they evolved their radio base stations or their products. And then in the end, the product was finished. Now we're going to be in operations. Around 2002, 3, 4, they introduced product lifecycle management as the core PLCM process across Ericsson. And I had the fortune to be part of that journey in a small, tiny bit, and I learned a lot. And what we were having at some point, we asked questions. We were discussing, are we trying to be customer-oriented or market-oriented? Trick question. Customer-oriented for Ericsson meant we build something bespoke for one single operator, versus market-oriented to try to build something that more than one operator could use. So provider and market. Productization then, if I use the word productization, it's about thinking about how we interact in a large enterprise or with our end customers in a way that we are productizing these relations. Now, this is the kicker. Decentralization. What do we want to do with decentralization? We want to create an opportunity for interoperability and network effects. So the whole idea with decentralization is that in order to scale, we need to decentralize in order to be more nimble and fast. Fantastic. But if we can't have network effects, if we can't reuse, harvest and reuse from what is happening in different parts of the organization, we have an adhocracy. So decentralization, these interfaces put in different parts, is really important. Now, if we think about that, if everybody out there is doing their own interfaces, that's not going to work either. So this is where the federation part comes in. It's a point where we have platform. It's a point where we have a team topology with platforms and that serves more other tech teams that might serve an end customer. So this topic of product thinking relates to platform teams working towards their customer, domain teams working towards their customers. Not easy this to get right. So ultimately, decentralized ops should be about product first in the ways of working. And what we are trying to do is we're trying to get market agility and scalable ops. We're trying to get both. If we get that, we have now trying to see and think about how can we get value creation. We have a user, we create value for this user or this team. And on the other hand, how do we capture that value back into the enterprise so we build value, and ultimately we are working towards market adoption on the one hand side, and we're working towards capitalization, doing things cost effectively, doing things that scales. So this is the macro level story. I move down on a more tactical level. Product first means how do I think about my process and what we do so I have usable design. So the way we are designing an algorithm, our data, or even our BI app, is it usable for the user? On the other side of product as interface has to do with composability, has to do with are we really thinking carefully now of how we have built this? How do we build this modular? How do we organize this modular? If I take this story now all the way down to the operational level, so we start working on and discussing on a level where we actually can do the real work, we're having the three dimensions of usage, productization, and composition. And the idea here is that any team, if it's a tech team, if it's sort of in the back end, if it's a domain team, or even if it's a process in operations, every team in a big corporation, I propose, need to think about usage. Who are we doing this for? What value are we creating and contributing with? How do we productize ourselves? How do we think in such a way that it's easier to adopt us? And how do we productize ourselves going back? How do we compose our organization so it basically has a good fit for what we are trying to do? What I'm proposing here is basically trying to get the mechanics into product-first ways of working. And basically, what we're dealing with here is a value productization loop. I will decompose this a bit, but these usage, productization, and composition, they interrelate. They feed off each other. The tricky part in a large organization is that you have HR will compose organization over here. The designers in marketing will compose usage over here. And the people building tech and building operations in the middle. And we have a problem when this loop doesn't happen in a good way. So let's look at value productization loop in use. What do I mean with this? Well, if you go this way, it always starts in the domain. It starts with the usage. It starts with the problem we are solving. We have a problem space. We explore, we validate, discover, define. We diverge. We're trying to really understand what the problem is. Then we close this first loop. We do the develop and deliver. We explore the solution space, and we validate that. Here now we have the first loop. It's a normal double diamond, method in design thinking. Quite interesting. If you talk about domain-driven design as a software development methodology, it's essentially the same thing. We've seen this before. What's the third loop? The third loop has all to do with the organization space. So when you come from, you have thought about what you're gonna, problem you're solving, what you're gonna solve, what you're gonna build, then you need to understand how will I organize this? How will I organize the tech, the architecture, but essentially the team and the team organization. And the core topic here is that this is ultimately a triple loop in the mind. So what is the use of this? So here we have now, on the one hand side, if we go all the way in the triple loop, from discovering continuous value, we're always starting with the value we are trying to understand, to continuously understanding how does that impact our design, and from design, how do we decompose that into organization, into teams, into tech, into architecture. So there is a very clear path here from continuous value to continuous design to continuous organization. So this is the market agility part through continuous adaptation. If I flip it and look at the other way around, what we have now when we are building more and more stuff in a way that is reusable, when we constantly think about how we organize stuff, what should be in the platform team, what should be in the domain team, what type of features can I have in a platform team where I can serve many domain customers, and then in the domain, etc., etc. Continuously understanding that we're building innovation capital in this way. We're building an opportunity to then use that to actually derive new products, new business. It's very simple. The more data we have organized that we can use, the more algorithms we have organized for a use, the distance to create new value on top of that is compounding. So bottom line, what we're getting to then is trying to sort out how to think to balance and work towards market adoption and working towards capitalization. How to work on value creation and value capture. So what I have done now here is trying to have a conversation on the mechanics that we need to go towards. But this is hard. This is extremely hard. I put to you why this is hard in some companies. You can find quite easily by looking at the trajectory of a tech startup. If I take Spotify as one example, versus a large enterprise. I can take Scania, I can take Vattenfall, I can even take many different companies that has a proud analog history. In a proud analog history, with a proud analog history, there is more of this. We have process, we have projects. We have not really structured our funding, our organization, our way of thinking with a product mindset. So when we come out and we say, oh, I want bucket funding for my product team. What do you mean products? We are building data projects. You know, you have an initiative, and we have thousands of initiatives, and we are trying to manage this. So this is really, really hard. I have an anecdote right now on the value productization loop in practice. So right now, with one of Data's clients, we've been working with a data strategy. We've been working on something that is essentially a very new context, a new company is being formed with new situation on how we need to meet the market. and essentially how to serve a much larger market and a much larger scope in terms of serving one brand to serving many brands. When we did this work, we were trying to really nail what are the no regrets use cases, what are the things in usage that we really need to have in place when we go live with this new company. And then from here, trying to sort out architecture, you know, all this. When we have come a far way, then you start sequencing how do we organize this in terms of what to build first, and if we're going to build this first, what is the team composition we need? So I have a very experience right here and now that has been very much in a very short period of time trying to get this done. But what we all realize, the mind trick, the hard part here is that we realize, who works on this on quite more tactical and operational level, that we will continue to do this story over and over again. And we now need to explain that to the board. We need to explain to the board that we cannot set this organization, it's going to be done. Then we're going to have a too fat organization for the big future. How do we start? How do we think big, start small, scale fast? So these mechanisms, I think, is really crucial to get right. End note on decentralization. So the key theme here has been how we decentralize data and AI value creation. I've highlighted product-first thinking to emphasize how we build interfaces and how we now, with the value productization loop thinking, a triple diamond, so to speak, how we can think about that. In reality, decentralization is super hard. So the question is, do we have a choice? You know, can we live with only point solutions? I don't think so. Can we truly live in a monolith, in a central platform? I don't think so, because we have ecosystems evolving. So depending on how you look at it, we have a central system. We are the system. Well, you're the ERP system. That's just one part of the company. We are the central system. What are you talking about? This is the cloud system. You're only doing OLAP. OLTP was over here. All right, so we have two monoliths, whether we like it or not. And then we have point solutions because we can't do everything in those platforms, or it doesn't work that way. So decentralization is hard. A core mistake we're doing with decentralization, I've heard it when we talk about data mesh. When we talk about data mesh, we put the large emphasis on we are domain teams, and we are decentralizing, and we are talking about that. But there's one very important principle here, which is really about the platform teams, serving the domain teams. Product-first ways of thinking, understanding decentralization, understanding maybe the federation part even more, I think is one of the key things to reflect over, and that is what we mean with decentralized data and AI value creation. With this, I want to end this opening remarks, and I would like slowly to get Jan Bosch up on stage as our first keynote speaker. Mr. Jan Bosch, please join me on stage.
What are you doing? I mean, I walked into this place and I went like, holy cow, what an event. So what I wanted to do is to ask all of you to give the Data Innovation Summit team a big applause for organizing such a fabulous event. Let's start with that. Woo! What an incredible place to be. I'm so excited to have 20 minutes, actually 19 minutes and 40 seconds with you now. But what I wanted to talk about is where AI is going. Because we all know what happened with AI, right? You bring all the data to a central location, and then you use your GPUs and all your advanced infrastructure to do all the training, and then you get the models that you think are good, and then you distribute them to wherever they need to go in a static, non-changing format, because you've proven the thing in a centralized fashion. And I think that that's great, but I don't think that that's where the world is going. Where I think the world is going is from offline, centralized ways of working with AI to online and decentralized or federated ways of working. And why do I think that? Well, there are a number of reasons. The first is, if you are a European and you look at the European industry, you probably understand that all of us are very much involved in embedded systems. If you look at cars, if you look at telecom systems, if you look at mobile phones, if you look at other devices, we have millions of instances of these products out in the field. All of these products have a lot of computational power, they have data storage capabilities, but we are not making use of any of those capabilities that we have at systems in the field. So in order to make use of that, we need to not only move the inference, so a static model out on the edge, to the edge, no, we have to actually move the training out to the edge as well. We have to get to a point where systems are continuously training themselves and are continuously improving themselves over time. And in order to be able to do that, we need to move from centralized, offline ways of working with AI to online and federated ways of working with AI. And that's what I wanted to talk with you about in the coming 17 minutes and 45 seconds. Is that okay? Is that a good topic? You want to know more about that? Yeah, are you sure? I have other presentations, but they're on my other computer. Yeah, so what I wanted to do is briefly tell you who I am and where I come from, then spend a minute on this concept of digitalization, which I think is quite important. Then talk about what I believe are the challenges of centralized and offline AI, move towards explaining and talking a little bit about what federated and reinforcement learning are all about, give you some examples that one of our PhD students, Hong-Yi Zhang, is working on, and then move to conclusions. So very briefly about me, I used to be a young and innocent professor of software engineering. Then I went to work for Nokia. You remember Nokia? Yeah, it was a fun company, right? Well, as good as long as it lasted, and then it stopped. Then I moved to Silicon Valley. Now I do a whole bunch of other things, among others angel investing. Come and talk to me if you're starting a company. And according to my PhD students, I'm now an old, grumpy, and cynical professor of software engineering, as you can tell, right? But the main thing that I do is I run something called Software Center. Software Center is a collaboration between, I think, 15, 16, 17 companies and 5 universities. Typically large companies. Some of you may actually be working at the companies. For instance, Grundfos, I know that some of the people from Grundfos are here. And the focus of Software Center is to significantly improve the digitalization capability of the European software-intensive industry. And how do we define digitalization? We define it as software, data, and artificial intelligence. So that's what I do for a living when I'm not on stages like this. Then if we talk about digitalization, I think everyone talks about it, everyone has an idea about what it is, but for me, the essence of digitalization is a fundamental shift in how we deliver value to customers. Yeah, I often use my car. I drive an Audi A4 as an example. I've owned several Audi A4s, but every time I get the car, it is the best it will ever be throughout its entire economic life. And from that point on, it will get a little worse every day I use it, until I'm so sick and tired of the old clunker that I go and replace it with the next car. The next car is a little better than the previous one, but it still gets worse every day I use it. Digitalization fundamentally changes that proposition. The day I get the product, it is the best the company that sells it to me or offers it to me can make it, but it is also the worst it will be throughout its entire economic life. And from that point on, the system will become better every day I use it. And how does it do that? It does that by, for instance, pushing new software to it, improving the AI models in it, sometimes even periodically replacing the electronics in it, but the basic value proposition is every day my product is a little bit better than it was yesterday. That is the essence of digitalization. And that brings me to a general reflection on how do we deliver value to our customers. What I think is important to realize is that we have been on a journey where the speed and the frequency at which we deliver new value to customers is increasing at a constant fashion. We used to work in product generations. If you're in automotive, every 5 years there's a new platform, and the new platform provides new value to customers that the old platform didn't. Then we moved to yearly software releases. Anyone who has to work with the latest upgrade of Oracle or SAP or whatever knows what that is like. Once a year there's the new version. It's a huge pain in the neck to actually upgrade, so you have a few weeks of hassle, and then everything works and you move on with your life. Then we moved on to DevOps, Data Ops, ML Ops. And what we now have is a feedback loop where every 2 to 4 weeks there is new value coming out to people to our customers. But it doesn't stop there. The next step is, of course, A/B testing. I give some customers A, some customers B. I measure which of these two is performing better in the field. And based on that, within a few hours or a few days, I can decide everyone gets A or everyone gets B. And now the last one, of course, at least the fastest that I know of, is this whole notion of reinforcement learning. What I do is I have elements of my system, certain aspects of the functionality, where the system fully autonomously experiments with its own behavior in order to improve the value that it provides to customers. And now I can get results or improvements within minutes or within hours. So we have a constant shortening of value delivery cycles, and that is the essence of digitalization. I have a complex model that in the interest of time I'm not going to go through, but if you're interested, come and talk to me afterwards. It also has an AI dimension at the top, where I believe that we're moving from static human interpretation of data to autonomous experimentation. It's too complex, but in general what we see is that companies that build software have 3 types of software development going on. The first is traditional requirements-driven development. Boring, but still necessary. Then we have what we call outcome-driven or data-driven development, where a team is basically asked to move the needle on a certain KPI. For instance, on websites, this is often conversion, but in other systems, this may be other metrics where a team is basically asked to go and experiment and try out different ways to move the needle on a certain KPIs. And of course, the last one is AI-driven development, where we use large data sets to train models that are then put in operation. If we look at how most companies that I work with are actually working, most of them are still stuck in a traditional requirements-driven way of working. They use hardly any outcome-driven way of working, and now some companies are starting to use the AI bit a little bit. This is where I think we need to be. We need to get rid of requirements to the largest extent possible. We need to become much more clear on what KPIs are we actually wanting to improve to deliver value to customers. And of course, we have to make more use of AI. So why am I so excited about events like the Data Innovation Summit? Because everyone here is concerned about making more and better use of data, which is exactly concerned with data-driven or outcome-driven development and artificial intelligence. Now we go to AI. I wanted to talk a little bit about what I feel are the challenges of centralized and offline AI. And for that, I will start with the very basic AI life cycle. The hard part in AI it's basically a 4-step process. I get the data, I create a model, or I improve the model, I train and evaluate, and then I deploy. And the interesting thing, which annoys me to no end about the AI community, is everyone and their brother is talking about models and about training and about results, as if that is the hardest thing in AI. And you know the interesting thing? All the companies that I work with, what is the hardest from an AI perspective is not the models and the training and evaluation. It is actually getting high-quality data in trustworthy data pipelines and being able to deploy models in a way that is safe, reliable, and secure, and that allows me to monitor the performance of the models, allows me to raise alarms, allows me to trigger automatic retraining of models, etc., etc. The hard part is not the model. The hard part is everything else around it. That's the hard part. And we worked on that because we developed a concept that we called AI engineering. There's actually an academic conference that I happen to be the general chair of, kicking off on Monday next week, where we basically put a research agenda together of all the challenges around the machine learning or deep learning model that need to be in place in order to successfully deploy machine learning and deep learning models in an operational context. I have a whole bunch of PhD students working in this. If you're interested in any of this, come and talk to me afterwards, as I said earlier. But the challenges that I see of these offline and centralized training is a couple. One, we have millions of embedded systems in the field, and the European industry is especially strong in the embedded systems world. What I see is that all these devices in the field are collecting data, but the communication and storage costs are so high if you bring everything to one location that all the companies that I work with are working really hard at limiting the amount of data and filtering the data that is basically pushed to the cloud because of cost reasons. So what I run into is a situation where the amount of data that I have available in a centralized offline context is actually quite limited. Even though I may have terabytes of data, it is still a fraction of the data that I have available to me in the edge. Yeah, so what I'm looking for is that we are now training machine learning and deep learning models on a highly limited, highly curated set of data, because the amount of data that is available through all our devices in the field is simply too large and too expensive to all bring to the cloud. So what we need to is to find ways to work in a much more decentralized fashion than what we're doing in the past. And not only that, if I have a central model and every device in the field gets the same static model, it is unable to adjust itself to local circumstances, and it can't do the mass customization that we're looking for, where my car, for instance, in the adaptive cruise control feature, adjusts itself to the ways that I like my adaptive cruise control to work. I want it to not work like everyone else. I want the bloody thing to adapt to me. Now, for all of you that have adaptive cruise control in your car, you know that training does take place, but you are the one training yourself on how to effectively work with the adaptive cruise control system, whereas I want the system to adjust to me, not the other way around. And of course, one of the big challenges is as well that data privacy and security is a major issue if you bring everything to a centralized location. So what I believe is that we have a tendency to copy AI approaches that work well for systems, software as a service solutions, so cloud-based systems, to the embedded systems world as well. And I believe that that approach is not optimal for software-intensive systems where we have many copies out in the field. So very quickly, because I'm starting to run out of time, but what I wanted to spend is a few minutes on the concepts. I guess all of you are quite aware of it. But in the case of federated learning, what we're basically doing is inverting the flow of what is actually being distributed. So in a traditional system, as I mentioned, you have edge devices. They are pushing all their data to the central location, and then the model gets distributed to the systems on the edge, so to the edge devices, and I do all the training in the center, in a centralized location in an offline fashion. In federated learning, what we do is we basically do local training using the data available to us, and then we distribute model updates to a global model that then gets aggregated, that then updates an update of the central model that is then distributed again out to the edge devices. And this is an interesting thing. The edge devices don't have to take the model update. They can actually compare their local current model performance with the central model's performance. And if the local model performs better, the edge device can actually reject the new model. So we have a way in which you can start to see a deviation of models in the field because systems adjust themselves to the local circumstances. So we have a number of benefits of this. Of course, this is data privacy preserving. Even in high security situations where companies don't want to share their data, you can do the training locally on the company's premises and only share the model updates with each other, so that every company that is willing to share model updates can still benefit from an improving model, but they never have to show or share their data, which I think is a very valuable one. Second, most embedded devices or edge devices actually have a lot of excess computational resources that are not used all the time, so we can make use of that. We can have fast deployment of things, much smarter models, and we have enormously much lower bandwidth needs in order to make this happen. Now, federated reinforcement learning, I guess you all know how this works. This is online. The system basically observes its environment, and then based on that decides to take an action that influences the environment. It gets a reward based on that, and the idea basically is for the system, for the agent, to maximize the reward. So rather than having a data set and then training a supervised model, what you do is you have a system that basically experiments in its own behavior in order to get better. If you combine these two concepts, what we run into is what we call federated deep reinforcement learning, which is one of the examples that I'm going to show you in the coming slides, where what you do is you give every edge device a deep reinforcement learning model, and you do the same model updates, model distribution pattern that we have with federated learning, and then you can actually have a situation where you can have hundreds, thousands of millions of devices all training concurrently and sharing the wisdom of what they've learned with each other so that everyone gets better at the same time. I believe that this is where the future of AI is going, especially in this software-intensive systems world. Some examples. We started this many years ago with one of our former PhD students, David Isamatos, with a Swedish telecom company that shall remain unnamed, where we basically went through the model of dynamically and automatically adjusting parameters in a base station in order to maximize, minimize connection time and maximize the number of network elements or mobile devices that could be connected to a base station. This is many years ago, and we had a multi-armed bandit approach that I can show you here, where we basically were looking in a kind of reinforcement learning approach for the best settings in this particular context, for this particular base station with this set of network elements or UEs. So that was one case. Another case is that we looked into a steering wheel angle prediction, where we had simulated together with a Swedish car company that shall remain unnamed, but I think you have a guess, where what we tried to do is we tried to do real-time, end-to-end federated learning with an asynchronous federated learning algorithm, where we were able to use multiple instances of the same system using different data to learn basically collaboratively what is the best steering wheel angle prediction that we were using. I am almost out of time and the thing is starting to blink. Then with another company, also a telecommunications company, we started to look into flying base stations. So how do you optimally position a flying base station to optimize the backlink and the uplink for those of you that use telecommunications. So this is a system that is in real time adjusting altitude, position, and antenna angle in order to optimize throughput. And of course, we had to expand that scenario to multiple UAVs or multiple base stations where you have multiple flying base stations that are jointly, collaboratively adjusting position, altitude, and antenna angle in order to optimize things. And that leads to wonderful results that I don't have the interest in time to show you. But interestingly enough, we actually got much better results with this algorithm than with any of the other approaches that we had been using before. Conclusion, 14 seconds. Yeah, this guy got it almost right. George Colony, former CEO of Forrester Research. In the future, all companies will be software companies. In the future, all companies will be digital companies. Software, data, and AI. And then the final things, and I'm out of time. Key differentiator in Europe is embedded systems. To build on that, we need to move from offline and centralized to online and federated. If you want to learn more, send me a mail at jan@janbosch.com, and I send you free PDFs of all those books except the one in the upper left. And with that, thank you very much for your attention. I really appreciate it. Woo!
We did it on time.
Almost.
On
Thanks.
time for the actual live stream. That's the production part. Now we can relax for a couple of minutes until the next live stream starts in 5 minutes. Right?
It was wonderful. I love being here in Stockholm. It's my 9th trip here.
9th trip, yeah.
And my best.
Love it. What do you think about this?
It's beautiful. Thank you all for coming here and attending.
Yeah, it's great. So I think I'm going to leave you to the stage. You have 30 seconds until the live stream starts, so you can crack a joke. You can do whatever you want with the audience, and then the live stream, introduce yourself together so everybody online hears it as well.
Sounds good.
Take care.
Thank you for having me.
See you soon.
Do I grab
you have
that?
the clicker?
All right, we have 18 seconds. Anyone have any jokes before we begin? So we're just going to wait 10 seconds for the live stream to start. I could juggle, but I only have one thing. All right, well, thank you all for joining and for everybody on the live stream. It's wonderful to be here. Stockholm and Sweden has a big place in my heart, which I'll be talking a little bit about in the presentation. One of the 3 topics is with Raoul Wallenberg, and I'm the president of the investigation into the fate, and he is here. He was born, raised. The Wallenberg family is fairly famous. If you were here yesterday, Marcus Wallenberg himself was one of the keynoters. And usually when I travel around the world, very few people have heard of Wallenberg. And I ask for a show of hands, and very few people, but I'd love to do it just once. If anyone here has heard of the Wallenberg, hopefully everybody who was here yesterday. And that's wonderful to see. I'll talk a little bit more about it, but I'm going to attempt in the next 20 minutes to have 3 separate stories, one on Raoul Wallenberg and another on Moneyball, which is sports analytics, and how that is a great example of how the world has changed through data and AI. And then the next is data lakehouses, which is one of the current revolutions in the field of data and AI, and take you along that journey with me. So it's been a big honor to have worked in sports analytics for many, many decades. I'm known also a little bit for that movie Moneyball, which is a great example of how data has changed in industry, and really it's the culture around it, which we're seeing here in all of our industries. In some industries, there's been resistance to change, and as I talk to people, there still is in some degrees. And on the other hand, especially in the last couple of months, large language models and so on, the whole dialogue has been a big shift from what is AI to maybe we should dip our toe into it, to now we're seeing full on of what is it, how can I implement it, and large language models is just one of many instances where the whole world and every aspect is changing. So here's a little diagram about different aspects of my life. One of the big achievements as part of the team was creating, after the movie Moneyball came out, got some visibility, was brought on to the Chicago Cubs to create and lead their analytics department to evaluate players, to evaluate trades. And on the top left, that's them winning the World Series for the first time in 108 years. Trivia, there are 108 stitches in a baseball, and that's the exact number of years that they did not win the championship. And the gentleman, number 44, Anthony Rizzo, I was one of the people, but I did the analytic analysis to do a strong recommendation for him to come onto the team. So it was a huge team effort. The moment that the ball touched his glove, they won the World Series. And talking about Wallenberg, one of the things that I really hope everyone takes away is not just your current job, but how can you improve the world? And AI for good and data for good is one of the things I take personally. So on the bottom right is one thing that one of my friends was imprisoned for a crime he did not commit, wrongfully imprisoned, and using data and information and a lot of work, we eventually got him. He was life in prison without parole, but we got him out of prison and he's free. So that's one good thing, if nothing else in life, that I could be proud of. And then merging on to technology, at one point I was the president of the worldwide Oracle user group at the time that they acquired Java and SQL, MySQL, PeopleSoft. So we saw this revolution from like no data to Oracle doing the databases, and we'll be talking about data warehousing, data lakes, and then this new paradigm of the lakehouse. And we also saw revolutions in mobile technology. So let me step back towards Raoul Wallenberg. I think most people raised their hand, but there are some people I talked about that hadn't heard of him, but briefly, wonderful humanitarian from Stockholm, from the famous Wallenberg family, that during World War II had this humanitarian mission where he rescued in various dramatical ways directly 10,000 Hungarian Jewish civilians from the Holocaust, and indirectly another 80,000 by stopping this massacre of the Budapest ghetto. I encourage you, if you haven't heard the story, to please look it up. very daring parts, but the tragedy is he was arrested by the Soviets in Budapest after the war ended, and he disappeared. So it's been one of the biggest mysteries of the last century of what happened to him. So it's very important to commemorate what he did historically, but it's also extremely important for the whole world, especially for Sweden, to help really understand and unravel what precisely were the circumstances of his fate. So I've been part of this investigation for many decades to have hands-on experience to go into the Soviet, now Russian Gulag prison system, use data science and analytics to enter information, all of the interrogations, eyewitness accounts, transportation studies, to see what happened. Long story short, he was arrested, sent to different prisons for two years, and then claims that he died, but there have been significant eyewitness accounts that he was held in prison called Vladimir, where all of the international prisoners were kept. So many, many credible eyewitness accounts of dates, including some of the staff there, the people that would serve food. So the goal was to take these card systems, and hundreds of thousands of them, and enter all the cells of where people were. So you can see on the left the actual records, and then make a database, and then you can use artificial intelligence and just general analytics to see what every single day of every floor of every cell of the prison, and who was there and who wasn't. So were these eyewitness accounts credible, or was there some conflicting, like another mistaken identity? So that's what we've done. The investigation was fairly successful. Prisoner number 7 was a very likely outcome, where he could have been given a 25-year prison sentence in Vladimir, and then possibly died. If you go to the Army Museum here, they have a box with his belongings that were given back to the family. But long story short, the only empirical evidence-based investigation into that fate. And you can see the card system of what it looked like. For more information, ralphsfate.org, as well as the RWI, the Raoul Wallenberg Institute, are great ways to keep up with what happened. So that's like one data journey, using information to find what happened to an extremely important case. The next is the movie Moneyball. I'll do a show of hands. Has anyone heard of that movie or seen it? Wow, a lot of people. I was actually on the plane, long flight over as I came over, but it's basically an aspect of one of the stories of my life. I'm extremely pleased to have worked with Major League Baseball organizations for many decades. And when I started, I was a fan, and I realized, just like you might see in your industry, things that were overvalued or undervalued didn't quite make sense. Some very good players would have bad statistics and vice versa. So I was a teenager, woke up, and came up with this idea: if you see the letter X in statistics, like expected goals now in European football or expected wins, that was just this paradigm that I thought of that made sense. It's a team sport, so sometimes what your value is really a factor of how your teammates have performed. So the slogan, adapt or die, is kind of an interesting one. And it's also applicable every single industry with artificial intelligence. You don't want to innovate or adapt just for the sake of adapting, but in many cases, if you're not changing, your competition is, the way people are consuming is changing extremely rapidly, and a year or 2 or 4 years from now, things are going to be extremely different as well. So for me, personally, I like to change up what I'm doing every single year, and especially in sports, if you don't change every 4 years, you become less and less relevant. And the nice thing is, after the movie Moneyball came out, it inspired a whole generation. In fact, there's now college courses all around the world on sports analytics and sports business. So wild to see. When I started, there were only 4 people employed by a sports organization, to now see it an entire multi-thousand person industry. And you may not be able to read those actual numbers, but this shows that analytics absolutely changed every single sport. And those lines going up are an indication of strikeouts in a game, higher than ever before in history. Something called shifting, where you use only data to position where a player might be standing to anticipate a ball being hit to them, doesn't cost you any more money. But when we first started doing this with the Cubs, only 3% of all balls in play use this information to defensively position. Only 3%. And as of last year, it went up to more than half of all balls in play, since the data showed it was extremely helpful. In some cases, you had an 80% better chance of making an out than without the information. And it would win about 8 to 9 more games per year, which is roughly $80 to million more dollars for a team per year, and the difference of making the playoffs or not, just from using information and nothing else. And then the bottom left is another sport, basketball. Totally changed the game. The NBA went from mostly 2-point shot attempts to mostly now 3-point shot attempts. Completely game-changing. And how is this achieved? There's an explosion of data throughout every industry, and especially in sports. Now that you can incorporate video, you can do things like automatically tag, just from a video, different body parts and see how that moves in 3-dimensional space. Then you can take, one of my favorite parts of the data science process is feature engineering. You could take information and say, this is an arm, but the sequence of movements is somebody running across the field, they're kicking with their left foot. And then I had this wonderful conversation before about OKRs and how do you measure people's success at a company on a business perspective. And it's not just an individual contribution with OKRs, it's really a team contribution. Same thing in sports. It's not just scoring a goal, but what are the sequences that lead up to a goal? And also in, like, for example, retail or sales, it's not just you made a sale, yes or no, but what is that sequence of events that led up to that sale? So in sports, it's fascinating. You can do feature engineering like in financial analysis. It's not just the price or the earning, but you can come up with a new feature, price per earning, that could be even more predictive than those two fields individually. So you can get very creative and eventually win. Now, in addition to Major League Baseball, got some visibility, so ended up working in lots of sports. And last year, I had a very fun job traveling around the world with McLaren and Formula One racing, helping out with their race strategy team to figure out all sorts of use cases. When will it rain to a 5-minute increment? What will the track temperature be or the air temperature be? Better predictions than what the weather station could do. Using high-definition, high-speed cameras to see if there's debris on your tire or your opponent's tire. And that's all streaming data, real-time, 80,000 car parts, 300 sensors on a car, sending information 1,000 times a second, and figuring out actionable insights from that in real time. So in addition to numbers, one of the things that Moneyball taught me and working with McLaren and other teams have taught me is that there are humans behind everything. From an engineering standpoint, yes, mathematics can help you aerodynamically help a car, but in the end, it's athletes. And by putting yourself in their shoes, you could see as you go around a turn, your head's twisting and it's changing your perspective. And that would trigger an idea, and I would then work with some of the drivers, Daniel Ricciardo, Lando Norris, to help with the training exercises with their physical trainer. So all of that is to get into the seat of, in your case, your customer, your partner, the users of your whatever you're selling or producing, and get it from their perspective, since it's humans that are actually making the actions in most cases. Going from there, let's kind of start transitioning towards the lakehouse. And through every industry, it used to be data warehousing, where it's numerical-based insights. And now there's a wealth of new types of data, typically video, geospatial, text information. We talked about large language models, time series, and visual information. So about 85% of the data out there, some might be even more, is this unstructured data. And almost all of it is unused. So this is a big challenge for companies. They're collecting and storing data, and it's just kind of sitting there unused, or maybe they're just looking at a historical perspective. So one of the trends we're seeing is gleaning information from all of this. And multimodal is being able to make the best predictions using both structured and unstructured data. So there will be winners in every single industry, those that are able to extract the most insightful and actionable insights from all of their data. Everyone wants to now, in the last couple of months, start leveraging all of their data. It's an incredible time to be part of this. And this conference has been wonderful in the education. But a lot of companies are struggling. There's two very different paradigms of information out there. Your structured historical data in data warehousing, and then your machine learning unstructured data in your data lakes. Companies want to go along this maturity curve from old reporting information to being predictive to actually being actionable, to automatically, in some cases, taking action when certain events happen. And it's unnecessarily complex. You typically need about 6 different vendors, multiple different platforms, leads to a lot of challenges. Like if you're just doing a predictive analytics on both video and information, it's very hard to do unless you have one unified platform. Also, the governance and security. If you have 2, 3, 4 different ways of security, understanding the lineage of the data from its raw form all the way through the structured form to the ETL process to the machine learning, you really should not have more than one governance. So this data lakehouse is the new paradigm, and every company will be having one form of data lakehouse, and so it only makes sense to have both your structured, unstructured, backward-looking, forward-looking information all in one place. And another theme is collaboration, the teamwork of Major League Baseball, the teamwork of sports. Everyone's pulling in the same direction. And then the same paradigm, everyone in your company, from technologists to data engineers to data analysts to non-technical people, the business people, all need to be part of the same collaboration. So having one in the same platform with the same common definitions, the same standards, only makes sense to have that in unified. And the foundation is on the cloud as well, cloud and on-premise. But for the cloud, companies now are becoming so complex that multi-cloud is part of it. And just a quick second about Databricks, a company I'm at. Encourage you to go to the booth to learn more or come to our website. But been fascinating to be part of this journey. We are heavy on the open source. Our founders, actually our co-founder Ali was grew up in Sweden, in Stockholm himself, or Uppsala. So we have that Swedish connection. 5,000 employees and a large foundation on open source. One of the things that was fascinating is just how prevalent this open source is. 43 million downloads of Spark and MLflow and Delta Lake. So I have less than a minute left. Let me jump forward. A lot of great use cases. Just to kind of leave, go to our website if you're interested. Especially, we came out something called DALL-E, which is a large language model, all on open source, freely available. We have notebooks you can learn and share. We also have Data and AI Summit, virtual or in person, where you can learn all about that. And I wanted to thank you all for those 3 different acts. Hopefully, one of the 3, 2 of the 3, but really, hopefully, all 3 of them were of interest to you. I'll be hanging around the booth. Please connect with me on LinkedIn if you'd like to continue following or you want to reach out to me personally. And again, I hope you all have great success in all of your journeys, and thank you very much.
Thank you so much, Ali.
My pleasure.
We're a little bit on overtime now, so this is not on the live stream anymore. But what made you go so deep?
Welcome back, everyone. We are here at Data Innovation Summit 2023, and we have another awesome product demo for data scientists. I am now joined by Timothy from Kibula, who's going to walk us through a tool that will make your life easier. Is that fair to say?
Easier and better, I would say.
All right, cool. So what's up? Show us.
Yeah, so we're going to be speaking about modern data products powered by AI. At the beginning, I'd want to just quickly touch on the history of the company itself, because it might be brand new to a couple of people. And I always think it's quite important to understand why technology was created in the first place. And we have a truly unique history, which really embodies our ethos as an organization. So who created the platform? It was created by our co-founders back in 2008. They were just a consultancy back then. And they just created the platform so they can better serve their clients, right? And if we fast forward just a couple of years, they delivered a project for our now CEO. He gave them a timeline of roughly a couple of months. They delivered it within a couple of days. And our CEO, or Pavel, who had the project get run by, he traditionally ran these projects and knew you needed a team of 5 people, you needed a couple of months to deliver. So he was more interested in how did you do it so quickly compared to the actual project itself. So they kind of brought him in, showed him what the tool is all about, and he said, you shouldn't keep this in a consultancy, you should take this to the market instead. So that's been kind of where we start from. So since 2014, we adopted the SaaS model. And kind of where is Kibula today? Well, we're a data stack as a service. From 2014, starting to service all of our customers, around 250 worldwide now, 1,000 plus users, and some of the latest additions from the Nordic market is Pincho Nation and Paradox Interactive, which are quite exciting brands, and hopefully there'll be a customer story coming out soon about them. And data stack as a service, probably a term you've never heard before, right? Right, so what is that all about? So we're trying to solve a problem, of course. And what is the problem? Well, we see quite a lot of organizations go down this DIY stack route of trying to stitch together several different tools. So some sort of solution for data ingestion, some sort of solution for data exploration or warehousing or data science, orchestrations, reverse ETL or outputting data. And on top of that, you need to have some sort of custom development. So if we talk about, time to market is quite slow. You would have to build, manage, operate, and maintain this custom data stack. Scalability is quite limited if you want to bring on more use cases, more data, so more tools, more people to manage this, right, and operate it. So if you look at cost of ownership, it's quite high. Scalability can be quite limited because you need to expand your team. And you always have to deal with maintenance or creating custom development. How do you deal with versioning, sharing, backups, archiving? And it's quite a fractured system when you stitch together several solutions. So how does user A in solution A match user A in solution B? Or how does X dollars in solution A match Y dollars in solution B? And how do we attribute that to our use cases and do some cost attribution?
I think it's intimidating for a lot of organizations to manage this puzzle at the beginning of their journey.
Yeah, managing this, and you can bring someone in to manage it for you and create it for you.
Yeah.
And then when they move on, they take that tribal knowledge with them.
Right.
And you need to bring someone in who understands this custom stack that they built and all the intricacies around it. And very difficult, very expensive, right?
Okay.
So what is a solution, or what is our solution to this is, Keboola, right? So it's one managed unified platform, taking you from the point of data ingestion to putting the data into any sort of visualization or data consumption layer. So time to market is accelerated. It's an off-the-shelf, managed, optimized platform that is ready to go from day one. You don't have to wait 3 months to try and build it. Scalability is quite seamless. We manage all of the infrastructure for you and provision the resources you need to accomplish the different use cases. We have customers with just one person on the platform accomplishing all their use cases, customers with 100 plus users accomplishing their use cases. So when we speak about cost of ownership, one platform, one charge compared to several tools, several charges, a lot more cost effective, right? Bottom line for business users, right? It was always
Okay,
great.
so you have one tool here, and can you run it on-prem and in the cloud, or is it cloud native?
So this is cloud native.
Okay.
So it's mainly in the cloud on AWS, GCP, as well as Azure.
Okay, so you can run it on all 3 clouds.
Agnostic.
And then is it entirely managed, or can you can you sort of sit and fiddle with knobs yourselves and that kind of, so to what degree is it managed?
So all of the underlying infrastructure is managed for you. Of course, you can always fork or edit any sort of the configurations that we made in terms of the components. So if you do need to tailor some of the components for your needs, you can also do that.
But out of the box, it handles that stuff for you?
Out of the box, it will handle it for you.
Okay, cool.
And if we look a little bit more about data stack as a service, so setting up a data infrastructure takes time. It takes key decisions which revolve around how do you do data modeling, how do you deal with infrastructure, how do you deal with governance. And when done right, this really makes an organization flourish. When done not so right, can really limit an organization as they grow. So the challenge is usually these architectural designs are done at the beginning when you're in data infancy or when you're starting your data-driven journey, so to speak of.
Right.
So as the company's requirements change over time, as they develop over time, you need an architecture that's dependable so you can operate business as usual, but flexible enough so that you can actually adapt to accommodate all of these new use cases the business demands. Right? And at the end of the day, I believe we have to remember that it's actually the people who use these solutions and these tools that are the data heroes, right? They're the ones who help the company to become more profitable, save money on automation, find new ways or new revenue streams within the organization. And the tools are just there to empower them, right? It's not the tools doing it, it's the actual people doing it. So that's kind of why I wanted to speak about our company's history, where we came from a consultancy switching to SaaS, because we really encourage all of our customers or anyone new who's interested in Keboola to speak about their interesting use cases or their edge cases and how we can accomplish those together, right?
Makes sense.
Yeah, perfect. And if we speak a little bit more about what can you do in Keboola, right? So what can we actually do?
I'm curious what it's made out of.
Yeah, pretty much. So we have the data sources on the left. We need to bring those into storage somehow. So we have out-of-the-box components or extractors for you. That will be stored in Snowflake by default. We are powered by Snowflake, so we are partnered with them. We do also have several other integrations available, but we're true believers in
What do you
Snowflake.
mean other integrations?
Oh, we can also connect to Redshift or Synapse or
Okay, so this central pillar out of the box is Snowflake.
Yes.
But if you really want to, you could run it on Redshift and what else? What kind
Synapse,
Okay.
BigQuery as well, XSL, and if you really wanted to, but we're big believers in Snowflake. But we will tailor towards any sort of customer's needs.
What do you have on Azure? You have their SQL. Could you run it on their sort of managed SQL Server type things?
Unfortunately, not as a backend. So it'll just be on Synapse.
see.
But we can connect to their Microsoft SQL and ingest that into their Synapse instead. So you'll still have access to all of the data if you want to really consolidate your data.
I suppose I would imagine it's because you make use of a lot of the type of automated functionality that's available in these kinds of systems, scaling and all that kind of stuff.
Yeah, exactly. It's all built around it. And then if we speak about bringing the data in as extractors, which are just as any sort of ETL tool, right? Bringing data in, we can then transform the data, manipulate the data with various sort of backends. We don't limit you to any sort of language. If you want to work in SQL or Python or DBT, Julia, and we will have a new feature which I'll highlight soon for no-code transformations for business users as well. You can have interactive workspaces. It's a personal sandbox to really explore your data, understand it, really go crazy. Nothing you do there will damage production whatsoever. And you can plug in third-party applications to enrich data, build data apps with Streamlets or data products.
Would you say that this system is more tailored towards code developers or no-code developers, or what's a typical user of this system?
So I guess a typical user would be some data analysts, data engineers, data scientists. And where we're going is we want to enable or lower the barrier to entry for business users without restricting technical users. Because a lot of the time when you cater towards business users, you have to restrict technical users, which is what we're avoiding here, right?
Right.
So it's one environment, one platform where business users with no-code transformations, which I'll speak about in a second, can work on the data themselves, self-serve themselves. If they run into any sort of blockers, they can have coders come in and actually help them with their transformations that they're trying to do. So it's all within the one environment themselves. And the platform is API first, which means the UI is just an abstraction of those APIs, so you can really build on top of the platform and extend it. And there's also the CLI available, which is also an abstraction of just working with those APIs. So if you are a code warrior or code hero, you can just work in the CLI and never have to look at the UI again.
Nice.
But everything is still tracked. Users in the CLI, users in the UI, users just using the APIs, all tracked within the same system.
You said that you wanted to get more business users using this interactively and that kind of stuff. And one thing that we've been talking about in all these panels here for the past day has been the word data management and everything surrounding that kind of stuff. So how would people be working with data management on Kibula?
Well, I mean, if we're speaking about access management, we can make several different environments. So within Keboola, we have something called a multi-project architecture, where you can create several different environments. Each environment has the exact same features, same functionalities, and it will be completely up to the client. How do you want to break up your environments in some sort of business logic way? So you could have L0 to L2 acquisition layer to data maturity doing data science, right? You can have technical environments, non-technical environments. They can't break any sort of pipeline, production pipelines. So that's all handled within the platform as well.
Okay, neat.
And then I guess the last step is always how do we consume the data, right? So we have writer components or reverse ETL to bring that data into any sort of visualization tool. We're very agnostic when it comes to that, as well as any sort of SaaS applications that you'd be using to actually visualize the data. And this is all within one platform. Everything is tracked, monitored for you, and everything is optimized for you already. So you don't really have to care about what's underneath, right?
SaaS applications, that's sort of cool. Do you have an example, like what kind of a consumer would live on the front side of this platform?
You mean the consumer from the data consumption?
Yeah, from a data consumer, taking things out of the platform, like what would be?
Bringing it back into Salesforce, which is one of our use cases.
Salesforce, okay, yeah, that makes sense.
I mean, or any sort of CRM management tool, any sort of dashboarding as well. So it really depends on what.
So like Power BI or something like that.
Power BI, Tableau, Looker, ThoughtSpot. Whichever it may be, right? We're agnostic to it, so it's really dependent on your needs.
You might be agnostic.
Yeah, I mean, we may be agnostic, but maybe the clients aren't ready.
All right.
And if we speak just a little bit about the features, right? So no code, what is no code? So it essentially allows business users to build data products without coding or any sort of IT, clean data with just a couple of clicks, as you can see on this very nice graphic, all the different processes you're able to do, and you're collaborating with coders in the same environment. On the back end, it's essentially a DBT transformation. So coders can just edit the DBT transformation themselves, right? While the business users are just using the very nice UI.
Right.
So accommodating both, allowing them to collaborate in the same environment together. And then we're going to speak a little bit about templates, right? So these are predefined use cases. You can deploy an end-to-end pipeline in just a couple of minutes. Just need to authenticate some of the data sources or the consumption layer. Business users can self-serve with any sort of template that we have. We have around about 40 out of the box available.
What kind? Can you give me an example of a template?
Yeah, bringing marketing sources into Snowflake, bringing marketing sources into Google Sites, for example.
Okay.
Ingesting data from databases, taking it to ThoughtSpot for some visualization. So we built quite a few data templates with them. And this is also supported within the CLI, so coders can use this as a springboard to accomplish their use cases for development. You can build your own custom templates in the CLI as well.
So these are like data flow templates and not just things in the user interface that you can choose. But so if a CLI user wants to use that flow template, they could use that as well.
In the CLI they could use that as well, but they could also build it as well. But it's a whole pipeline that's pre-built. The code has been written, it's been pre-configured. All you need to do is authenticate it, right?
Then that means that all these sort of data flow automation tools that capability is built into Kibula.
Built into Kibula as well.
Okay.
So everything you need for data prep for your consumption layer can be accomplished within Kibula essentially. The last one I wanted to talk about briefly was just the activity center. I spoke a little bit about we maintain or we track your metadata and telemetry data. So this is kind of the end product of that. So this is just to give you a brief example of what is possible with that data. So we can track based on credits, based on security, and based on health, right? So security, who's using MFA, who's failing to log in, who are the new users in the platform, who's creating new API tokens, for example. We can track all those. If we're looking at credits, how many credits do we spend today? How much does this specific use case cost us to run? Does that make sense? So we can do cost attribution, which is very difficult to do if we look at the original problem of stitching together several tools. How do you cost attribute dollars in solution A to dollars in solution B in relation to all the various use cases we're running. But if it's in one platform, you can track it, right?
Right.
And that's what makes it a lot easier. Then also the quality of your environment. How many configurations are airing out? Which user has the high error ratio, so we know where to assign internal resources, which environment, which team has the high error ratios, or optimizing. Which transformations aren't using tables, which tables aren't being used in storage, for example. So you can get full observability, 360 essentially into your environment itself. And now we get into, I guess, the crux of the presentation itself, so AI for data businesses. So what essentially does that mean? Well, I like to believe that Keboola has been somewhat at the forefront of transforming, companies with AI products or making it easy for you to harness the power of AI. We have, many different success stories under the belt, which are available on the platform or on the website itself, where customers are using Keboola to build AI products, right? So Orphan Cars is one of the leading sellers of new and used cars within the CE region, and with they utilize Keboola with one of our partners, Marketing BI, to essentially collect historical data on purchases, competition, and behavior, and feed that into some ML algorithms. And then those AI algorithms essentially predicted the marketing messages that were likely to convert people to the website, essentially, or into customers on their website, so to speak of. And this is actually, we have a full customer story both on YouTube as well, written down, so you can really explore how they were able to do this by 760% increase in sales in a single quarter. We always like numbers, and those are high numbers.
Was this something that they put in Kibula, and then this was the first use case they tried, or did they have Kibula, and now they're like, we're going to try AI, and then that gave them the benefit? So how was that like for them?
I mean, I think a lot of organizations believe that. They think we can just start with AI, right? But the beginning is you have to have some data maturity. So what is happening in your organization currently? That's going to be the first layer. Second layer, what are our competitors doing within the market? What is the market currently? So that's bringing in external data into our systems, understand that. Now, when we have that maturity, we can look at, okay, let's do some AI, for example, right?
Yeah.
We have to build upon that maturity. We can't just start there. Right?
Yeah, well, I think one thing that people think is, if you have a scale from 0 to 5 in terms of maturity across a couple of dimensions, they think that they can jump ahead to stage 5 because they see, oh, I know how to do stage 5. And the way, Twitter is doing scale out, I want to do that too, because then I'm going to be like Twitter or something like that. And the fact is, the weakest link in these dimensions is going to hold you back. And then the second thing is that jumping ahead that far, it might not be the end game for you in particular. So, having one platform that sort of guarantees maturity across a number of dimensions at the same time makes sure that you're not going to have these weak points anywhere, so that you can actually, move on an initiative like this and actually get it done.
Yeah, exactly. And also kind of future-proofing, so we can meet customers at whatever data maturity they are in. If they just need to ingest and consolidate data and create some dashboarding, great, we can do that. But as soon as you need, in maybe 3 years, you need to start doing some AI or start doing some machine learning.
Right.
You can still do that within the platform. You don't have to go and get more and more tools, and then you bring in more and more complexity, more and more management, and people that will be required. So that's the whole idea behind the platform.
Okay.
Right? And now if we talk a little bit more about AI, how is AI used or utilized within Keboola? So currently we have a public beta where we're doing some data ops automation with AI. It should be kind of every data person's robotic friend. And coming soon is going to be a text-to-pipeline solution, which is very interesting. It creates a new data pipeline or a new flow or template, as we spoke about, from simple text instructions.
Right.
So that could be, Keboola, please connect my Google Analytics to my dashboard and show me which traffic sources are bringing the most amount of leads. And then the AI would build that pipeline for you, right? So can you imagine just how much of a benefit that will be for business users to actually self-serve that way? And we will be speaking a little bit later on about how that kind of works and how you can interact with it in the future. But if we speak a little bit about the beta features right now within the platform. So first is error messages. Usually error messages aren't so understandable, as you can see at the top here. It's not so clear what the exact problem is, right? So we're using AI to essentially make this more readable for humans. So you can see immediately, just at first glance, this is the error, this is my problem, but now what do I need to do? So this is a potential solution to fix it.
That's great.
And people or anyone can already use this within Keboola, right? And we've been demoing this yesterday, we'll be demoing it again today as well. So this is just the first beta feature available. The second one is AI for descriptions, and this is usually where governance comes in, right? So to have good data, who did this, how did they do it? It all starts with descriptions, it all starts with documenting. So within the platform, you can add descriptions to anything. Pipelines, transformations, extractors, anything you do within the platform can be documented or can have a description to it. And this is where AI really helps. Because we track your metadata for your tables, we can auto-generate the descriptions for you. So we take away that headache of the chore, right? By keeping best practices in terms of documenting everything within the platform. And this is also available in public beta right now that anyone could use within the platform. Last 2 slides, I know we're a little bit over time, but I promise you it's worth it. We are hosting our Empower event series, which is an online community series. Anyone can scan this QR code. It will take place on June the 14th, all around AI. So what super cool AI features are we currently working on? So text to pipeline, we'll get a little bit of a sneak peek of how that actually looks like in real time. How to implement, run, and truly reap the rewards of AI, and what are the pitfalls to avoid when we speak about AI. Just like you mentioned, we can't just go from 0 to 5 immediately, right? We have to build up to it. And last but not least, how to get hands-on. Everyone's favorite topic, how can I play with your tech, right? So you can actually scan this QR code. We give you around $100 of data processing for free every single year. No requirement, no credit card needed. So that would be the best way. Then you can also find us on Azure Marketplace. So you can use your Azure credits. Otherwise, Snowflake, Google, and AWS is coming soon. And last but not least, exploring use cases in our demo project. So our product team has created a demo project called demo.keboola.com. You have read-only access. You can't break anything, don't worry. But it's a guided walkthrough of the platform itself, the UI itself, and actual processes running, so you can see how does that look like in Kibula without having to create an account if you don't want to. And those are the different ways you can get hand-on, or you can always just come to our booth and say hi to us today.
I think that sounds like a good idea. These guys know what's up. The only way to evaluate a product is to actually get your hands on it, so kudos on that. Normally I have to ask people how they can actually try the thing instead of just look at the slides. And I heard you're quite the demo wizard, so get in touch with these guys and give the demo a try if you liked it. Hope you liked this product walkthrough. Thank you for joining us, and I will be seeing you very shortly at the next session. See you all. everyone. We have another expert session here, product demo and expo of capabilities. I'm joined by IBM. Please introduce yourself.
Hi everyone, I'm Annalise, and I'm a data and AI leader at IBM. You might have heard that we've announced WatsonX, and so I'm really thrilled today to go a little bit more into detail for WatsonX .data, which is IBM's Data Lakehouses. And let me maybe start to play a video to set the scene a little bit.
All right.
WatsonX is.
AI. WatsonX. WatsonX.ai for new foundation models, generative AI, and machine learning. WatsonX.data, a fast, flexible, and open next-generation data store. And WatsonX.governance to enable AI workflows that are responsible, transparent, and explainable. WatsonX. Let's put AI to work.
That was cool.
Yeah.
Was that computer generated?
I don't know actually, so I will need to ask marketing.
I would presume there's something neat going on there. All right, well that looks really interesting. We're joined here by IBM. Please introduce yourself.
Yeah. Hi, so good morning. I'm Annalise. I'm a data and AI leader at IBM. And what you just saw is what we've presented this week at Think, which is WatsonX. And today I'm going to go a little bit more into detail about the WatsonX.data, which is our lakehouse. Maybe also to give a bit of context before I go into the lakehouse part is talk a bit about the WatsonX.ai and the WatsonX.governance. The WatsonX.ai is really where we want to help companies with their prompt tuning and also with fine-tuning their foundation models. When you do prompt tuning, you're not really touching the foundation models, but what we help to do there is also the prompt engineering, right? Like giving some handcrafted examples towards your LLM. So what we have there too, from in that studio for doing the prompt tuning and the fine tuning, is actually we have IBM's LLMs, which are really trained on clean data, right? We've been talking yesterday about governance, so pretty important. You don't want to be working on LLMs that have been trained on where there is copyright infringement. We also announced a partnership with Hugging Face, so you also in our studio you have access to all type of open source models, and then you can also just bring your own. But it's really a studio to work with generative AI models and LLMs. So really,
how does this relate to IBM Cloud?
Yeah, so it is available now on IBM. It will be available in July on IBM Cloud, so you can now already subscribe to.
That's the best and fastest way to get access to these tools?
Exactly. You can already put yourself on the waiting list, and then once it's online, you can just start playing with it. So.
Okay. Yeah, I think IBM Cloud is pretty neat. I've used it myself. And the one thing that's neat about IBM Cloud is that because it's a little bit newer than some of the old clouds, it can skip some of the old problems that they've inherited from having been around for so long.
Yeah.
So that's quite nice.
So no, and it's all built. It's also not like old IBM tooling that it's really
it feels fresh.
Yeah, exactly. So and then there is also the WatsonX.governance, which is a little bit again what we've been talking about yesterday. Is really how are you going automatically, to do all your governance around your model. So also things you can subscribe to and have more information about. And then I propose to start my slides about the WatsonX.data, so the lakehouse. Let me open it here. Nope, that's not the right one. I will need some assistance. Apologies for that. So I will already start, right? So first I want to give a little bit of context of what we've seen in the past, right? And so AI governance, we talked about it yesterday. What we also want is we want also to have that governance at the data storage level. So lakehouse, this is my lakehouse.
Okay, that's not a bad lakehouse.
Very, very quickly to set the scene, because we all know this, it's just to set the scene a little bit. when we query data, what we want is, of course, to have speed performance while having governance. All of that while we make sure that our costs remains in control. We all know there is lots and lots of data coming every year towards companies. They say 30% of increase in costs every year. And they're what we've seen in the past, right? So we were used to enterprise data warehouses that were super, performance was good, governance was good. But at some point, we wanted to work with unstructured data also. And we also wanted to avoid that vendor lock-in, which was also making the cost pretty high. Also for the story, I joined IBM 8 years ago as a Hadoop SME. So it's exactly what we were saying back then for the data lakes, right? Like, hey, why don't you take open storage to avoid vendor lock-in? So it was amazing. But first thing what happened, of course, was, well, the performance wasn't that great anymore, and it very quickly became a data swamp, right? Like, it was like, oh, well, 1 year ago, we put that data set there, like, what is it doing there, and who has been doing it? So that's really what we saw. We didn't have the asset compliancy, all of that. And then we quickly saw cloud databases coming in, right? There too, I think performance went up again. Also, the cost went up. We loved really the scalability about it. And I think then where we went towards is really the concept of lakehouse. It really brings together everything we like about an enterprise data warehouse, a lakehouse, and then also the cloud, right? So when we look again, right, enterprise data warehouse from a perspective when we segregate actually the compute, the metadata, and the storage, we see that your compute and metadata storage with an enterprise data warehouse is really tightly coupled. With the data lake, the metadata layer and the storage, it was already a little bit more decoupled, but still. And I think from the cloud data warehouse, that's where we clearly decoupled the storage. But what you see from a data lake house is that there is a clear decoupling of really your, well, we can also look at it here, that we have a clear decoupling of your storage, your metadata layer, and then your compute engines. From an IBM perspective, what we are proposing with WatsonX.data is really to have multiple query engines. So not only Presto, for example, for your BI, but also Spark for your analytical workloads. And what is really cool there is that you actually have a shared metadata layer. So that will really make that you don't have copies of data, because you only have, whether you're doing BI or analytic or machine learning on your data set, you really don't have that many.
Can you spend a moment talking more about the metadata layer? Because I'm not sure the audience is entirely familiar with it. I mean, I think everybody understands the idea that you can store data in your storage and that can be decoupled from your compute engine. You could use Spark, you can use whatever engine you want. But what does this mean? What kind of things would you have in your metadata layer? And what significance is it compared to the way things used to be done?
Yeah. So the fact that you can also, for example, attach it to our central governance layer. So what we often see, right, is that you have, when you're enforcing your governance policies, is that you have them at file level or at application level, and you have to recatalog them every time. Here, right, it's built in, and you can connect it to our governed catalog, such that you just catalog once your data, right, and you will have it really shared across any storage or any engine. And maybe I can go a little bit more into detail, but that's really the concept of it.
And this has to do with all these data governance concepts that have been floating around the past day or two that everybody's talking about. This enables that.
Yeah, and it's really built in. And again, it's what you often see is that, well, you see lake houses that are only using Presto, and then you have a lake house that is only using SQL. Right. But then you need 2 times the same data set.
Right, I see.
Then you have very separate metadata, and then you have to recatalog it twice to say, well, these are your governance policies, this not, right? So that's really that's really what we thought a fit for purpose. So whether it is your BI that you're doing, whether it is machine learning, based on an open lakehouse architecture, supported by the querying and so on. So just the three key benefits.
Yeah.
And that's all I will talk about, and then we can, go a little bit more into detail. So
Yeah.
what are the three key benefits, right? Is that you can access all your data across the hybrid cloud. So whether it is on-prem, whether you have still the data lake on-prem or in the cloud, also your enterprise data warehouse, you can just connect to them all. Again, have that shared metadata layer, so that's really key. And as I said, right, because you have cheap object storage, you have that shared metadata layer, and there's multiple query engines. You only need one time your data set. You don't have
Right.
copies, which helps your governance, which helps your security because you don't have multiple data sets flowing around. And again, with AI governance, we said, it's super important. The second part is you can really get started easily because you can connect to your analytical data set, and then you can just start because you have your shared metadata layer and you have those multiple query engine. And then you can reduce actually the cost of your data warehouse because what you do is you can actually do workload optimization across multiple query engine and storage tiers. So what you're going to do there is really to say like, hey, which workload do I have and which query engine? Like, do I need a really expensive one because I want it to go really fast? Or do I take a cheaper one and I have a little bit more time? So the price performance metric,
Right.
you just choose it on the fly. Like you are more choice. It's not like, okay, that's the only way I can access it. So it's always expensive or it's always, not a bit cheaper. So this is the first benefit I was talking about, to go a little bit more into detail, right? So we have object storage and Iceberg, so as a file format. So Iceberg is really giving you that asset compliancy, the rollback features, everything we loved with an enterprise, with a transactional database, but something we didn't have back in our Hadoop days with the data lake. And so you can have Spark, Presto, data warehouse, and then, as I said, you have that shared metadata. So you share one single copy. The second one is that we're still in that first pillar of benefits, is that you can connect across the hybrid cloud, right? Often you see that other lakehouses, they're just on the cloud. So because we are really, IBM stands for a hybrid cloud and AI, that's what we do. And for mainframe customers, it's also possible to synchronize and incorporate DB2 for ZOS.
Oh, wow.
And then the second is what I said, you can really get up to speed in very quickly, right? So you can connect your existing analytics data pretty fast. The second part is what I explained, that you can connect to our central governance catalog. So it's a catalog where you not only have your metadata about your data, but also about all your analytical assets that you have within your company. You have, for example, also semantic expansion, right? Like when you're looking for, hey, I need business info, it will just tell you, well, here is the email address, here is the contact, the phone number. It's something that we see that our customers are really asking for. And then you have automated policy enforcement. So again, it's built in. You catalog it once, and it's got really enforced at all those levels. So that's really the key there. And then really fancy is because with WatsonX.ai, we are providing those LLMs that you also can now put into WatsonX.data. So you can use foundation models to discover, augment, refine, and visualize WatsonX data and metadata. So there too, we're really bringing that generative AI capability even at our lakehouse.
Gluing it all together,
Yeah.
in a sense.
Exactly. So yeah.
Well, speaking of that, I mean, some of the things that you've shown here are tools that are open source and have open standards. You talked about Spark and Presto and Iceberg.
Yeah.
Are all these things a black box, or is there some way, for example, to? I mean, it's very nice that Spark is a part of it. I guess what I wonder is how much, if you're the kind of person that likes to fiddle with knobs and that kind of stuff.
Yeah.
How possible is that? Is it fully managed and don't worry about it?
Yeah.
Or if you're really into that kind of stuff, can you adjust things yourself?
Yeah. So from a perspective, it's quite like. Let me also show here a little bit, right? So, of course, because the storage it's open, so this is really where it's ecosystem infrastructure, but that is pretty much, like you said, the first part, right? It's pretty much aligned and it's done for you. So yeah, it's
But
all
there's still a
aligned,
lot
but-
to choose from. Look, you have even Avro.
Yeah, so those are really your data format. Like Iceberg, that's our 5 format. But yeah. So I think it depends, right? So.
But this is a fully managed platform, so I mean,
Yeah.
when it comes to scaling out and that kind of stuff, a lot of the
Exactly.
troubles that you might be wrestling with if you're trying to run your own Spark cluster on-prem,
Yeah.
hopefully you won't be having to worry about that kind of stuff.
Exactly. I think that's really what IBM stands for, right? Like, we're not trying to be better than open source. I sometimes have customers like, but you're doing what open source is doing. Yes, of course, but try to build it on your own and try to maintain it. You will soon become maybe also yourself a software vendor, right? And it's not salesperson that are saying that in IBM. It's really the technical people. They've seen it multiple times where companies, they try to build their own platform, all with open source. But once indeed you put it in production in a company environment, you have those governance controls, you have scalability. There is so much that otherwise you need to maintain yourself, and it's not always possible. So we really try to bring that open source part to it and then make it enterprise lab ready and scalable, right?
Well, as a Hadoop SME, I think you have to sympathize with that. Troubleshooting the JVM is fun the first time, and then after that, you don't really want to be wasting time doing that anymore.
Yeah, exactly. So yeah, that's a bit what the things like, Hadoop execution and all of that, the push down. So
One time, okay.
Yeah.
Then somebody else can take care of it.
Exactly. So yeah, this is coming back again of what I was saying. Maybe I can go back here, right? So just to reiterate a little bit, that's the third pillar I was saying, that you choose actually, your fit for purpose compute and then your instance type. So you're really going to say, well, when I'm doing ETL, I want Spark, and as an instance, I want my compute. For BI, I want to use Presto, Cache, and then for machine learning, I'm using Spark and then compute, right? So that really brings, as we like to say in analogy, if you're on a highway where you need to pay toll and it's super fast, do that. But if you want to, it can be a little bit slower, and you don't want to pay that much, you can also choose to really optimize actually your workloads. So together with your compute. So this is again, right, saying that we have our multiple engines, a little bit more showing which ones, the shared metadata layer, and then indeed our open file formats like Parquet. So that makes it like you can, of course, access them, right? There is no vendor lock-in. It's not like when you want to access the data that you have to go through us. Like you can still access the data. And then I just want, because sometimes I feel like everyone knows Iceberg, but sometimes people don't. So I just wanted maybe to reiterate what we were missing in the data lake times.
This one's a big one.
Is asset transactions, yeah, and your time travel rollback features, everything we like there. So
I think it's really cool that you guys have a couple of different options in the storage layer, because the fact is, even aside from shadow IT where people just buy whatever they want online, even if you're not a multi-cloud vendor or customer, you have your on-prem stuff, you don't always have a homogeneous environment.
No.
And the ability for a tool to be able to span across more than just one environment is very powerful.
Yeah, so that's also across not only cloud environments, but also on-prem, right? And that's really why exactly we acquired Red Hat, right? So it's really our forte. And that's what we see, right? Like you can access all your data quickly across the hybrid cloud, right? And then again, there's multi-engines. I'm reading my my title. And then again, that you can have analytical and AI workloads. So that's really, I would say the gist of it, right? So you have cloud warehouses, like if you look at it from public cloud to on-prem, and then structured proprietary to unstructured and very open.
Right.
You have their cloud warehouses, on-prem lakes, cloud data lake, and we can really access all of them, and as open as we can be, right? So.
Well, I guess people will have varying opinions on it. I think, was it us that talked about whether or not you should have on-prem data lakes?
No,
that probably wasn't our team, but we spoke about it yesterday, and at least at these tables, the overwhelming consensus was not to start developing on-prem data lakes right now. This is an effort in futility and in frustration, but if you happen to have them left at your organization, it's good to know that you can. There's a path to.
We did well our job back then, saying that you needed on-prem data lakes. But
everyone did, right? Back in 2009.
It was everything, cheap storage, and I came also from the AI space, so that was really like you go bottom up.
Well, I mean, the thing is that there weren't these ready-to-run, reliable, good soft services.
Yeah. No.
So, if everything that you want from an on-prem lake is available as a service and reliably,
then and that's of course what we say, right? Like you can modernize your data lakes with it, right? So because you're not going to move everything again, right? So you just want to access it. That's also a little bit where the data fabric structure comes in. And I think that's also what makes it really nice with IBM, right, is that because we have also the data, of course, data fabric is a concept, right, but we have the tools that support the data fabric approach, and that really helps. So it's not just the WatsonX data, but you can also connect it to our data fabric.
So for the audience that wants to try this out and evaluate and get started, what's the best way to get started?
So I don't have the link here, but I would just go on search for WatsonX. WatsonX and IBM, you will immediately get on the page, and you can just click on waitlist because it will be launched in July, and there will be to a certain amount a way to try it out. So I think that's really what.
Well, that's pretty cool.
And I think just the WatsonX, right? So the WatsonX.ai is what I just explained, like our tuning studio for LLMs. Then you have the WatsonX data, and this is really where the WatsonX.ai is giving those LLMs to help out with the semantic automation, while WatsonX.data then gives, of course, your curated or the right data to WatsonX.ai, and then part of it is also WatsonX .governance,
right,
where we are really making sure that you have trust, fairness, that we can monitor all of that. Within your models, right? And there also I would like to say, stay tuned with IBM. I hear a lot of people saying, yeah, we know how to govern conventional AI, but how are we going to do that with LLMs? Well, there's a lot of research we've been doing, and there will be in the future also in our products, they will come more and more, all those features available to be also monitoring. Of course, we have already a lot of them, but I think there are a lot of new ones that will come there too. So I would say stay tuned. Interesting times.
Awesome. Well, it's clear that there's a lot to dig into here.
Yeah.
That's all we have time for today, but thank you very much for walking us through. And again, check out WatsonX. And thanks for joining us. We're going to be right back in just a couple of minutes with another Meet show. See you around, guys and ladies. Hello, everyone, and welcome back to one of the most awesomest panels of right now, Data Innovation Summit 2023, day 2. I think we've all been burning both ends of the wick these days, haven't we? It's been intense, but I think it seems we're all in good spirits. We're here to have a little discussion about the modern data platform blueprint. And I have with me a couple of domain experts on data platforms, components, capabilities, and tools. This is very technology-centric, and it's funny, something that's characterized the talks we've had in the past few days is that I think everybody's said for many years that, oh, it's about people and processes, it's not about the technology, and it's sort of something you toss out there. And I think it's a little bit different this year because it feels like now that the excitement is on LLMs and stuff, the technology is taken for granted, and that's why technology is not important. Whereas before it was because people just didn't understand it, and so they didn't want to talk about it. But the only reason we're here, and the only reason we've ever been here, is because of technology. So to say technology doesn't matter, it doesn't even make sense. We're here because this is a tech conference. Okay, so that being said, I'm joined by 3 experts. Please introduce yourselves, and I'm looking forward to your opinions.
Hi to everybody, I'm Paolo Platter, CTO and co-founder of Agile Lab. And Agile Lab is a consulting company, but since a couple of years we are developing also a product that is going to change the way we see technology, platforms, and so on.
All right, that sounds exciting.
Cool. I'm Alex Dean. I'm one of the 2 co-founders of Snowplow, also the CEO. And Snowplow is 10 years old. We're a data infrastructure business, commercial open source, and we help brands to generate very rich first-party proprietary signal of their own customers on their websites, mobile apps. It's a real-time platform, and then we land the data in Databricks, Snowflake, BigQuery, etc., so that brands can do marketing attribution, digital analytics, next best action, personalization, all that kind of stuff. So yeah, great to be here.
Cool.
Heine Iversen, founder, CEO of Time Extender. The short version, we automate everything from connecting to the data source to deliver the data product on any cloud platform.
All right. So we have a gang of heavy hitters here at the table. I'm going to start off with one question. I'm actually going to divide it because there is a follow-up that I think is good here. The audience wants to know what are key capabilities of a modern data platform. I think I'm going to do like this. I'm going to ask for, it doesn't have to be the most important capabilities, but why don't you mention 2 capabilities that you think are standout when it comes to not a data platform, but a modern data platform. Well, so what would characterize a modern data platform if you give me two capabilities that you think are important?
I think right now what is really important is the data engineering experience. So what kind of experience we provide to a data engineer that need to create a use case since the functional requirement to the deployment in production. Because we have so many tools and data engineers have a huge cognitive load because they need to know every tool's documentation, how to code every single components and so on. So we should focus on reduce this kind of cognitive load and creating developer experience that are streamlining the process of creation of value from the data, right?
Developer experience, I like that a lot. I've been talking about why it's worth having a nice laptop. And people are like, why would you want your own computer? You can run in the cloud. And I'm saying it's because it feels good. You can't underestimate the experience of developing and being inspired, feeling efficient and that kind of stuff. So what do you say? What do you think is a defining characteristic?
I'm going to take 2 easy ones. So I'm going to take data sources. So you're going to have some sort of ETL tool. You're going to have something like Snowplow for the data sources. And then everyone here is building some kind of data gravity well. So what do I mean by that? I mean that all these organizations are starting to bring more and more of their data into a central lakehouse or warehouse, like a Databricks or a Snowflake or a BigQuery or a Synapse. You're going to have those 2 pieces. So that was, I think I picked the easy ones.
Okay. What about you?
I think I will take a different approach. I think it's very important that you're future-proof. And I think we should build based on agility. I agree we need to have, the developer experience, the data scientist experience is important. But I think we should make sure that whatever future data technology, database, storage that comes up, that we don't have to start all over again.
That's
Because-
awesome. So you're saying a tool that lends itself well to being destroyed, in a sense.
Yes.
I think that's always been a design philosophy that I think is worthwhile, that you design to redesign. You make the tables so that you can remake them, or you make even the platform itself so that you can rebuild it quickly.
And then remove the tedious work.
Yeah.
I mean, there's so many wasted hours going on with 10 different tools. We call it the Frankenstack. We're not really a fan of the modern data stack because it's too many tools and it's too much time wasted. So it's the more we can concentrate it, the more we can actually automate so that the data engineer can focus on what's important, the difficult parts, because there's always something that's difficult.
But that's hit on a topic I wanted to bring up, which is interoperability.
Yes.
So, I think it's 2023 now. Data teams are under a lot of pressure.
Yes.
They're under a lot of pressure. Organizations are under pressure. They're under pressure to prove ROI. And I think data vendors, the people in the modern data stack, there was an opportunity to do a lot more interoperability work, like fix the roof while the sun was shining, and that hasn't been done. And so now you've got data teams who are under a lot of pressure from the business to show results, and they're still trying to grapple with all these different tools and having to like manually plumb them all together right now. You see all the vendors here, right? Like gluing all that together is tough.
One of the things that I've been wrestling with a couple of my clients has been whether to install something that has everything, or whether to install the pieces piece by piece. Exactly what you're saying. There is a management overhead in managing a stack that is built of 20 components versus the convenience of having an all-in-one data platform. But the negatives of that data platform might be that it's lagging behind in one of those components, whether it's streaming or machine learning or something like that. How do you talk about the trade-offs of having one system that does everything versus being able to design the components piece by piece?
Personally, I'm a big fan of creating an ecosystem of platforms that are synergic, interoperable, and so on, adopting open standards to let tools and platforms communicate. Also because what I've seen on my customer, typically large enterprises, is not possible to have one single platform because of legacy. So at the beginning of data management history, maybe it was possible to have one single platform, but now the stratification of platforms is not possible anymore to migrate everything on a single platform with all the features inside and so on. So it's simply not feasible. So we need to move towards an ecosystem of platform where interoperability is a key element.
Yeah, I think it comes down to data maturity. So I think if you're starting out, you're just starting to adopt a data warehouse, then there's a great place for technologies like Keboola and Mozart data and kind of do the bundle, right? It's going to save you so much time. I think then, to your point, as you start to like reach the limits on one of those pieces and you want to get to the latest in streaming or observability, you're going to have to go outside of that box. And then I think to your point, like as you become more mature still, you're going to need more federated data mesh, very composable architectures.
I tend to disagree.
Go for it.
And the reason is that we have to define what a data platform is, right? And what the data platform is doing. So our approach is to say, okay, we need end-to-end. That means the data mesh, the data fabric. Yes, you can do that. You can do the data lake. You can do it, deploy it across multiple clouds. And I think that's what the developers, the engineers are actually asking for. So will you run into that trade-off? Yes, but I think most of the trade-offs I meet is actually kind of BS out there, because it's the developers who say, yes, but I would like to do something very, very advanced, having that fancy laptop, right? But I think when it comes to data and to solve that pressure from the business, we need to take a step back and say, always look at what are we trying to accomplish. And the goal is not to build a data lake or a data lakehouse or a data warehouse. The goal is to deliver some intelligence or some data to the business in the absolute fastest way. And sometimes then you can actually do with 80% in a specific area. That is actually good enough to serve the business. But of course, if you try to sit and map out functionality between solutions, no, a specialized solution will always be better than an integrated, right?
I think it's like every every hot debate in data, or not every, but a lot of them, come back to market segmentation problem. And we see that at Snowplow. When we're debating two different strategies, it's normally because we've got two different segments in mind. And so to your point, I totally agree, it is about business outcomes, but like those are going to depend a lot on the size of your company, how far you are through your like cloud journey, how far you are through your warehousing journey. So yeah, I agree with you, but I think, you know, different company sizes need very different things.
Yes, and everything will be a mix, right? You are hybrid. Customers are on 3 different clouds with the same data solution, but you can still orchestrate it within one platform.
Sure.
I mean, that's what I see as modern, is that you can cope with all the different underlying technologies, but you put this interface on top.
I guess
for
the
the
question
developers.
was more about technology data platform, not the overall practice, because if we talk about practice, I'm totally agree that a company should be able to employ multiple technology to create a data engineering practice. And inside the data engineering practice, maybe you can have also multiple patterns, like data mesh, data lake, and data warehouse, maybe in different areas of the company. Also because of the stratification, again, is not all black or white. But when it comes to technology data platform like Snowflake, Databricks, and so on, I think it's not feasible for a large enterprise to concentrate the entire data landscape in one single technology platform. That was my point.
Yeah, but I don't see that as the data platform. Well, that's why I see the data platform is something more holistic.
Totally with you when I talk about data engineering experience.
Yes,
this is the kind of platform that you need to build in order to enable people to extract value despite the underlying technology.
Snowflake is just a database, right?
There's an issue now. Well, that's the thing, right? Just the database is like Redis or something like that. So like even 12 years ago, you had Cloudera that had everything from data lineage to a million functions. Now granted, they weren't as refined as the tools we have today. The tools we have today are, and even Cloudera itself, I mean, are just leagues beyond. But in principle, it could do lots of things, and people ended up using Hive and Hadoop, and maybe some cool people use Spark. So basically, they used it like a database, and they had this titan of a platform just to do this one thin sliver. So conceptually, I have an issue right now with 2 things. One is enterprises investing in a platform that is enormous to do some thin sliver of work within that platform, and they're putting the cost up front.
Yes.
And now the money starts to burn, and they're like, we have to hurry up and try to find a use case that'll justify the cost of this platform that we've put into production. And then the second thing is, because this is like a monolith, they only really want to focus on, you know, maybe graph analytics or something like that, and then reporting or something like that. And they have all this other stuff that they have 0 skills in, and they need to start skilling up. And I guess my question is 2 things. One is I don't like the idea of spending money ahead of time before you have a reason to justify that cost. And the second one is in terms of sort of the skills. I don't want organizations to be forced to jump from maturity level 1 to 5. They should be allowed to mature 1, 2, 3, 4, 5, and justify all of those sort of steps forward.
Yeah, I have a couple of thoughts on that. So I think I take the point, and maybe some of these platforms have a bunch of tooling and features you're not going to need yet on your journey. But I think, you know, we're in a world where the data gravity wells are real. People are these brands are bringing more and more information into these systems. The siloed kind of systems that had their own data stores are being unbundled, like composable CDP. And so as you get more and more of that data in this central store, you kind of have to have access to all these extra layers of tooling, whether it's stream processing or ML or like SQL or drag and drop UIs, whatever, because you want to do all your use cases there. You want to bring all your algos to the data, and you don't want to have to say, oh, this doesn't work, so I'm going to have to move all of this data out of the gravity well into this other, like, you know, graph system or whatever. So I think it's inevitable that, you know, the Snowflakes, the Databricks, the BigQueries are going to have to add all this extra tooling and features around it so that you can do all your use cases there. Because, you know, it has to have the feature set for your most difficult future use case. And I think the other point is, yes, we're maybe spending a bit of money up front and, you know, storing all that data, building all this, but, you know, people said to Snowplow customers over the years, what are you doing storing your event archive? Like, you know, why are you storing customer behavioral data going back 5 years? that's a liability. And it's like, no one's saying that now with the LLMs. People are thinking, oh, whoa, I could like train against this like full archive of all my customer behavioral data. So my point is you don't know what use cases you're going to want to put live in the next few years because the market is just changing so fast.
But I think we also have there's a flip side to that question, is how many customers actually select Snowflake or Databricks and then they start. So they make the technology decision first. I mean it so many times. And when you,
I would say like
them,
almost the majority,
yes,
right?
When you challenge them, okay, so does it have to be Snowflake? Yes. We support Snowflake, Databricks, Synapse, everything. And Synapse, Microsoft Azure, they have a lot of those tools around. But I would say most of what people are building also on Synapse, also very, very large enterprises, they build a classic data warehouse, Kimball structure, defined model, and then they put Power BI and Click and Tableau on top of it. I mean, that is still 90% of what they use it for. And I think for that, unless you have a stream, I talked to a telecom company yesterday with 100 billion of records a year. Okay, you might need this performance, but 90% of what is being used out there can still be used just on plain SQL.
Yeah.
SQL running with cloud hardware can easily deliver the performance you need, right? So there needs to be something that will help them with these use cases. I don't know, maybe LLM, yes, can be that use case.
What's your take on this monolith ahead of time versus implementing single tools and then having to deal with the ecosystem? Because undeniably there's a management reduction in buying one of these shrink-wrapped platforms, so to speak.
Obviously, building an ecosystem is requiring more investment in a short time. Because,
is it though? Because like if you just build this one component, you're not paying for everything else around it.
The integration among multiple components,
like the technical debt builds up, maybe.
It's some way costly. So if you made a very good example, no? You buy Cloudera, you have a lot of components that are separate components, not independent components, let's say, but they are talking each other in a very good way. Same identity provider, same way for managing access control. So everything is uniform, okay? So you don't need to take care of this. If you start to build an ecosystem, instead you need to take care as platform team of creating such practices on top, like governance, access control, and whatever. So in the short time, it's costing more, but I guess in the long term, it's providing huge benefits because you gain the flexibility and the ability to innovate. Because if in 2 years, 3 years, new technology will pop up and will come in place, we will have the possibility to integrate new piece, maybe step by step, evolving the technology stack along the time. A lot of people that maybe invested heavily in Cloudera, and now Cloudera is falling behind a bit, let's say. If they want to move out, they have difficulties because Cloudera is not interoperable with the rest of the ecosystem. You need to move the data from one place to another. So in the long term, this is not enabling innovation, and it's a huge debt for a large company.
I think that's right. I think that to the interoperability point, I think we all should have done more work on open standards over the last few years, and I think there's good lower level standards like schema technologies and storage formats on Blob and stuff like that. But I feel like there's almost a missing layer of standards one level higher that could have driven the interoperability. So there's a lot of different data observability tools here today.
Yeah.
I haven't seen them kind of working together to create open standards for vendors like us to plug into.
They don't work together.
No.
The only, let's say, effort in this direction to me is delta sharing that is coming from Databricks. It seems very coupled with Delta Lake, but in reality they built a protocol. It's an open one, but we need to create adoption. So multiple, many technologies should adopt this open standard in order to
There's
create
many
this
layers at which it can fail the interoperability. I mean, if you consider Google Bigtable,
Right.
there's not almost even a format, but have you ever tried to extract tens of dozens of terabytes from Google? It's basically impossible.
Right.
Basically impossible. And then you have the technical hurdles, like the serialization formats and whatever.
Yeah.
That's another thing. And then finally, you have just the sheer volume of data.
Yeah.
Fact is, if you have a petabyte of data anywhere, doesn't matter how interoperable it is, it might as well just it's going to stay there.
Yeah, that's the data gravity point.
Yeah.
Yes.
So that is undeniable. And to that effect, I 100% agree with you with that the effort of moving stuff will sort of make things gravitate to these different ecosystems. However, I did hear an interesting comment earlier at another panel of a guy that said that the data is going to grow stale. Not in a bad way, but in the sense that it's okay that it stays there because as that well grows, we make a new one and it's sort of more relevant and newer and good data, and this one will eventually sort of evaporate in a sense. And so it doesn't have to be a problem. What do you think about that?
I think that's an interesting one.
You shouldn't just build on one forever. You should have new ones that you keep building.
Yeah, I think there's so I think there's two separate points. There's almost staleness, and then there's like, is it kind of future-proof? And so I think as long as you're serializing and storing it using good standards and schematizing it and structuring the data, then I think you can use it in perpetuity. Is it stale? Yeah, it could be. I mean, if you're like a very high transactional business and you only serve a certain cohort and people age out of it, then I guess by definition it's stale. But like, is anything stale in the age of like generative AIs and wanting to train LLMs? Like, they would love that data on like historical consumer behavior.
Maybe. We'll see.
We'll see.
I think we're going to be really creative when it comes to that kind of stuff because everybody, man, this was like a big myth about deep learning, that deep learning needs lots of data.
Yeah.
Just as a data structure, deep learning needs fewer samples than tree structures and stuff. So that's like wrong on a technical level. But I have a feeling that we're going to be able to use reinforcement techniques for models to oversee their own training and tag. So it's easier to be a discriminator than it is to actually produce a good output. So we might be able to have models that can pretend to be customers and have another model that's trying to serve relevant content, and the discriminator can say, nah, it's not interesting. And so we might not even have to have historical data if we can have a discriminator that's fairly customer-like and that kind of stuff.
No, but you need to know where they are, right? And that's why again, I believe that you need to have this, you call it blueprint, also in the thesis for this discussion. I think you need a platform that can give you the blueprint of what is my data sources, where is all my data storage.
Let's talk about blueprints, because blueprints embed best practice, or do they not? What do you think about that?
They go hand in hand completely. Because what you get from a blueprint, if you take the philosophy and say to design and build your entire data infrastructure, you just draw the blueprint. Forget about technology. We started with that in the beginning, right? If what we do, this is my data sources, this is what I want to happen, this is where the amount of data lakes or warehouses I want, data products for data mesh, and this is the underlying platforms or data structures I want to store it on. And by the way, this is just a virtual one over here, but if you put it all into one blueprint, you have all the metadata.
Yeah.
And the future, and the key for the future is metadata, right? Because with growing number of data sources, growing number of data, we need to understand that the business needs to understand to generate the use cases, what data is available, where is it? We also need to have, compliance, security, all that stuff. But if you can just do the blueprint, then you also become future-proof. Because then you have not made a decision that this is the tool I want to use, this needs to be on Snowflake. Yes, today, maybe I would move it. We have customers that take a solution that are running on SQL or Synapse and click 10 minutes later, okay, now everything is redesigned on Snowflake, right? Of course, then they need to make that decision. Do I want to move my old data from my Azure data lake, or will I leave it there and then continue? But then my data product needs to know this, so that my data product can then potentially be fed from both. That's how I define the future of data management.
This is a super interesting, and I think is related to the developer experience, because you can achieve that kind of control if you wire the metadata gathering in the development journey.
Yes.
Because there is a huge difference in providing technology as a service, but then after that you provide the technology, you don't know what is happening, and instead providing developer experience as a service where you have control on the experience because you have a platform team that is in some way providing such experience. And for example, there is a pattern that we advise that is the governance shift left. So pushing the governance duties into the development lifecycle. So developers need to provide metadata when they develop the use case. And we can assess in the CI/CD if the metadata is fulfilled, is completed, is compliant with the glossary and whatever before the data is going in production. Yeah. So to me, this is providing a developer experience and wiring in the process of value creation.
How big team do we need? I'm just wondering here, to do that with the stack and generate all these practices. How big is a data team? How many people do you need to be able to do that
in my
approach?
experience, the platform team, so who is developing such experience and integrating under the hood everything, it's 4 or 5 people, no more. Yeah. But this can generate huge benefits if you have 100 data engineers across the company.
I totally agree. I think there's 2 sets of shift left.
Oh, this is a great discussion. I want to talk about the developer experience because traditionally it's been abysmal. Everybody talks about data and it's almost like it automates itself and the developer's just sort of there to look at it, but the experience of collaborating with developers, setting up tests, setting up the business rules and stuff has been really abysmal up until now. But right, so keep going. We'll pin that because it's related.
Yeah, no, it's all the same topic, I think. So I think there's multiple shift lefts. So I think the shift left in terms of building these data products, you're exactly right. We have to have all the metadata, the understanding of the product baked into CI/CD, make sure they're really they're proper engineered products, right? Yeah. There's another piece of shift left, which is something we're working on at Snowplow, which is we've got to attach the metadata, we've got to do the structuring at the point of data creation, which is what we do at Snowplow. So we're building a lot of tooling so that when you send data into Snowplow, you're attaching schemas, you're attaching data structures. And that means that's shift left because it means that metadata is flowing through the whole system and you have that lineage. So, and we're baking CI/CD in as well. So I think as an industry, we're moving away from kind of ad hoc, let's write some SQL here and there, and let's bake shift left thinking, CI/CD processes and practices into the whole thing, because otherwise it's just ungovernable.
Let me tie this into the thing that I was thinking about.
That's because you want to do it like software development. I completely disagree that data products and data processes should be seen as a software development process.
Tell me, how should it be seen instead?
But I think if you look at from the modern data platform, I think where we are going also with LLM, I would say that it's much more about modeling. The data modeling with metadata will become the key thing because computers will generate all the SQL scripts. Most of what the data engineer are doing today when it comes to writing code and managing all that will be taken over by LLM models in the next week or 5 years. We don't know, but if you look into where the future is. So that we don't need 100, from my perspective, data engineers. We need a way to make sure that we can model and control, and that means that data quality and fixing data quality issues, metadata, documentation, becomes a much more integrated part, so that we will end up developing based on metadata.
Let me tell you, look, when I'm thrown into a project where capabilities are already set up, they say we have a data platform in place, it's capable of doing lots of things, which it is, in principle at least. And I'm thrown in as a developer, the first thing I say is, where am I allowed to put the data? Okay, we need to add you to an AD group. Yeah. Can't even get started on my work. Yeah. That is part of the developer experience. And it doesn't even have anything to do with the developer platform. Okay, cool. You have write access, you don't have read access. Okay, you know what I'm saying? So it's not even about how complex or not complex it is to set up CI/CD rules and all that kind of stuff. And I sort of agree with you. I think that given like a very structured API or whatever, machines should be able to do that stuff. But the process of me actually getting to use the system, getting my data there, evaluating whether I can I want to try out my little graph experiment and that kind of stuff. That is super hard still for some reason, because it requires 20 people to manage and set up the access controls and everything else like that. So I feel like the platforms are good as is, and right now we don't have processes, which is why I come back to the blueprints that I was talking about before. Can they sort of force people to work in a way that makes this pain of getting things going on these platforms that can do so many things minimal? And so I thought it was really awesome that you guys said that you only need 4 people. And we've seen examples of big CEOs this year kicking off 80% of their staff, and we're like, it doesn't run as well. Yeah, but he's running it on 20% of the people that used to be there, the same technical platform. Let's talk for a second about what you actually need to get started and be effective with these platforms. What kind of skills and capabilities or team sizes and that kind of stuff? What do you think about that?
Yeah, I think I want to answer that, but I also want to go back to your point, because I think they're both interesting. I think so. I think to get started, we've all lent on these kinds of generalists. A bit of data engineering, a bit of analytics engineering. They know enough SQL to be dangerous. Maybe they can build a couple of streaming jobs or whatever. I think to your point, I think it's interesting to think that, so I was talking to an agency partner the other day, and they write a huge amount of SQL. They use a lot of DBT. And they've started using ChatGPT, and they said it's pretty good, and they're going to use it more and more. And so I think what's going to happen is, getting started, like that generalist data techie, data MacGyver we call them sometimes at Snowplow, will be able to use ChatGPT to do a lot more faster. I think in larger companies, I think you're right. I think a lot of the kind of human middleware it's sometimes been described as, we still need those great engineers, those generalists, but I think they're going to be pulled to the first mile and the last mile. So what do I mean by that? The first mile means they're going to work to structure the data better for the LLMs, because obviously AIs are going to do better if the data has better metadata.
Yes.
So they're going to work first mile, and then they're going to work last mile doing the creative use cases, piloting, building, personalization engines,
so
or whatever
is cool.
Adding value, business value.
Business value, exactly.
Yeah.
Because that's what we need to get to, so it get away from that technology discussion, right?
Yeah. Right. And so how does this play into my question about team sizes in short term and long in 5 years, where we are now and what we should aim for? I think a lot of companies think, man, at some of my companies, you have teams that are hundreds of people managing a system like Databricks or whatever that in principle almost should manage itself, I think. Are these systems so complex that they need that many people?
No.
Or if they do, what should they be focusing on?
I think it really comes down to, because if you take the approach, which is a viable approach, to say, okay, but we want to build that for innovation, we're going to stitch together all these tools, and then we see Databricks as our underlying engine, or Snowflake is our engine, but we need, tools like DBT, we need tools like Fivetran, we try to put all this together, and I think that is one approach, and you will roughly need the same people as you do today. I believe that automation will go to a completely different level, so that we will see much more of these more holistic orchestration platforms, like Time Extender, what we are doing, saying that, yes, but just tell me what data sources you want your data from, and where do you want to go, where should we put it, so the first mile, and then put some more metadata on, and you're done, because then technology will take over the rest. We will just, build that data lake for you, or put it into Databricks.
You need to build such kind of experience anyway.
But you don't need as many people. I mean, I can see a lot of the customers that we win that comes from the stack. No, they go from 25 people in the data team to 4, taking care of both the first mile, last mile, and everything in between, right? That doesn't mean that these people are getting fired. It means that they can actually be utilized in new use cases that was piling up, but nobody had resources to do.
But I think that's an interesting point, because I think that as the data teams get freed up to do more business performance work and build more, last mile use cases, I think we're going to see a lot of disruption of industries that aren't here today. So I think we're going to see a lot of unbundling of other tools, and there's a term I really like called inverse Conway's law, which is, Conway's law is like, you ship the software that per the structure of your company. inverse Conway's law is the idea that your company has to change and adapt to the packaged tools it's buying. And so I think as our data platforms get more sophisticated, as we get more and more data in these data gravity wells, we're going to start saying, to your CRM provider or your customer engagement provider, no, we're going to unbundle you and we're going to build this on top of the data lake or the data warehouse using our own data team that have been freed up because they're not having to do this kind of plumbing work in the middle anymore.
That's an interesting idea, yeah.
Well, I think to your point about having 4 people in the team, and also you as well, is if you're pushing people out into the teams so that the stewards of data and the stewards of the data product and the AI product and stuff are part of the teams that actually get the value of it, it doesn't make sense to have them in like a gigantic monolithic IT group, right? Yep. So and that's a stronger evidence of what you guys are saying, that to manage the actual infrastructure as such, if we separate out all this sort of logical IT, it doesn't require a huge team necessarily, right?
And more important, if you can concentrate a team that is only working on platform engineering, let's say, this has the huge benefit that can be managed as a product itself. So it's not working project by project. Oh, please, place the ACL on this table. Oh, please open the ticket to do this and so on. So the platform team should work as a product team, and it can have a direct impact also in terms of return of investment, because if investing a certain amount of time, you are able to save 1 hour per week on hundreds of data engineers, you are generating a direct impact on the company. So instead,
who should be doing that work? That the ACL tickets and that kind of stuff. Where should that land?
What do you mean? Sorry.
Well, doing like access control and then that kind of.
You need to automate it. Inside
self-service or
some service where this could be totally self-service, and this is part of the developer experience, because when I want to develop a use case, I don't want to call someone and wait for an approval and so on. I want some automatic process that is delivering and helping me to unlock the next stage of my process. No?
But this would break down silos, which means that the IT group doesn't get to control that stuff anymore.
Exactly.
And I think that's right. Like at this conference last year, data mesh was a really big hot topic, and now everyone's talking about LLMs and generative AI. But I think the challenges haven't gone away, and the silos, I think, is still an issue. And I think as these data teams, these like central, capital D data teams are under more pressure to show results, I think you're right. I think we're going to see an unbundling where it's like we keep a platform team that work on all these difficult problems, and then I think the rest of the data team is going to get moved out and embedded into the line of businesses that are trying to genuinely use data to increase conversions, reduce costs, improve return on ad spend, decrease churn, all the stuff that we're all ultimately here to do, but we kind of sometimes forget about in the
What do you think the data team should be spending time making sure that data doesn't have personally identifiable information and that it's compliant, or is that sort of something that business units should be doing?
But I think you need to have it. It's a collaboration.
Yeah.
You cannot give it to the business alone, because there will be some data-related stuff that they don't know, and the data team doesn't know the business rules.
100%.
So what you need to do, again, is you need to do 2 things. You need to make a combined environment that they can work in, so that they actually work together, so it's not in different tools, but we're working together.
How far out can you push, though, when it comes to data literacy? Because obviously they won't know this data stuff, but how much should they know?
I think you can push it along if you incorporate a ton of automation into it, right? Because, again, fixing data quality issues, making sure you're compliant, like could be GDPR, PII information. I will say that with LLM models built into your stack or into our product, we will be able to spot 99.9% of this. We already have built in so that the data team can actually just mark, based on the documentation they get from the GDPR part, they can just mark what data in the data lake and data lake that is PII, And because it's one combined metadata solution with data lineage, you can actually then, that information flows automatically into the warehouse, into the data products, so that you are in complete control, and then the business can validate it. Oh, is this right? Or the DPO or whatever, depending again on how you're set up. But it all comes down to what we can do with metadata and automation, because that is going to be amazing.
Right. All right, so we have 1 minute left. I want to hear 20 seconds from each of you. What's the next big thing in data platforms? Go.
To me, the next big thing is platform engineering applied to the data ecosystem. So moving from single data platforms to ecosystem of platforms where we build experiences for data engineers. So for people, I identify data engineers not with people doing just the ETL, but with people that are engineerizing data to extract value. So the full life cycle for me is data engineering. So I see this platform engineering focusing on creating developer experience for data engineers, including generation of suggestion and support.
I love the developer experience focus. I think that's a big one. What do you guys say?
I'm going to steal AI-driven data modeling. I agree with you. I think that AIs are just going to start doing the middle piece.
I think
90% of the work we are doing today will be fully automated.
I think people think that this is something that's going to happen in 2 to 3 years. I think it's going to happen sooner than that. This is going to go really fast.
Based on what that agency was saying to me, it's happening now.
Yes.
That's awesome.
It is.
That's a great panel. We've chatted here for 45 minutes and it went pretty fast. Very happy. Thank you all for your insights. I hope you guys were inspired. Thank you for joining us. And stick around. We're going to have a little bit of lunch break now, I think. But we'll be back with some more exciting sessions. See you soon. Thanks, everyone.
Thank you.
Thank you.
Bye. Bye-bye.
Interesting.
That was
Welcome back, everyone. Data Innovation Summit 2023. We're back with another product demonstration and description. I'm joined by Cloudera. Please introduce yourself and tell me what are we going to hear about?
Okay, well, I'm going to talk about innovation in our platform. And my name is Wim Stoop. I'm the Senior Director of Hybrid Data Platform. Yeah, so we got a lot of things going on in our platform, lots of new projects. I want to talk about what they are and why they are relevant. I brought a few slides.
Okay.
We're going to race through them, and hopefully we'll have a chance to do a bit more of a chat as well.
All right, let's see it.
Let's go, right? So when I think about the platform that we have, it is built on 4 key pillars. And the pillars are, you need to be able to support modern data architectures, the blueprints and the paradigms that help you get to grips with more data faster. So that's the data mesh, the data lakehouse, and data fabric. Then it's also, you need to be able to deploy a platform across hybrid cloud. It's a fact of life. Everyone has got more than one infrastructure. You need to have data services, analytics that will seamlessly work between these different infrastructures to support these different architectures. And you need to be able to do that with consistent security and governance. But for now, for today, I just want to zoom into the data lakehouse. Because the data lakehouse is a tremendous concept. It solves an awful lot of problems. It brings together and it bridges the gap between a separate data warehouse with a separate data lakehouse. So as the definition states, it unifies that data warehouse and the data lake, aiming to support that whole range of analytical capabilities, not just one storage structure for one analytic. And the data lakehouse, it tries to solve these challenges. It solves the challenges of having to maintain 2 different stores of data, because then the moment you have one updated, the other one's out of date, it's stale. You need to do things in multiple different places, multiple different times, so you have reliability issues. You also have one place you need to go in order to do one kind of analytic and another for another. And as a result, it drives your cost up. You need to duplicate data, you need to duplicate processes. It just costs a lot. So the 4 key design goals of a data lakehouse are these. But how do you actually build a better data lakehouse, right? You need to make sure that it works with anything. It works with any kind of analytic, any functionality, on any infrastructure. And that's the second bit. It needs to be able to work consistently the same way everywhere. But then lastly, wherever it's deployed, however it works, it always needs to work best. So across these 3 dimensions, I'll be talking about some of the innovation that we're bringing in as part of the platform. The first one is, how do you make it work with anything, with any analytic? And for that, we use Iceberg. You may have heard of the project before. It's a project that was started by Netflix in 2018. It became a top-level foundation project in 2020, and it is seen as the next generation cloud-native table format. And as a result, we also recognize its dominance in the not dominance. Its desirability in the community, and use it for our purposes, which is really about driving that flexibility. There's a complete separation of the various partitions. It's completely hidden for the end users. Schemas can be evolved. It works on any data warehouse operations. It's fully ACID compliant, but it has very cool features that allows you to do time travel and rollback, to ask for what the results are from a particular query at a particular point in time. But most importantly, it works with masses and masses on data, petabyte scale data with incredible performance. So with Iceberg, you can start to address some of the challenges that previously with just a data warehouse or just a data lake were completely impossible. You can make sure that you meet your requirements from a data protection and data regulation perspective. The right to be forgotten, for example, as part of GDPR. You can make sure that you can use petabytes upon petabytes of data for either traditional analytics, but also what we're looking to do, and we're talking about it here in the conference, machine learning. Machine learning for any models, and even large language models.
Right.
But equally, historical reporting, to have the ability to go back to a particular point in time and say, this is what the answer to that question was. This is exactly what Iceberg offers. And we have a couple of customers that are using this with tremendous effect. There is the financial service organization that was just required by law to be able to answer that question, what was your state at that particular time? So time travel allowed them to meet their needs from a regulatory compliance perspective. There's a system software organization. They just spent more than 6 hours just updating their data warehouse. And while they were updating it, they couldn't actually query it. They couldn't use it. As a result, because you now have automatic snapshotting, you can just query your data while new data is being loaded in. You can have near real-time analytics. And then the last one is a car manufacturer. Self-driving cars, it requires a tremendous amount of data, but also car production. It generates a tremendous amount of data. How can you still maintain performance when you're dealing with such volumes? Well, Iceberg allows you to do just that. So that was the first one. How do you make it work with any analytics at scale? But then the second one is, how do you make this work everywhere?
Right.
Because so far, I think the majority of people listening will have thought, well, this is good. This is public cloud, right? This is a scale.
Yeah, when they say everywhere, they actually mean everywhere as long as it's these three public clouds.
Yes, but what if you are very security conscious, you're very highly regulated, and you want to make this work on premises? Well, then you need an on-premise object store, and Ozone is that on-premise object store. It's another Apache project to provide the ability to deal with structured and unstructured data at any scale for any applications. The purpose is to make this accessible. But, and here is the kicker, it helps you drive tremendous scale, it helps you drive tremendous performance, so supporting also the Iceberg performance. Looking at the benchmark blog that we have on that, for example, you see how Ozone performs better in some of the benchmarking that we have. It provides you the ability to have much denser storage nodes, 4 times denser than what traditionally on-premise you would do with HDFS.
Yeah.
It scales millions upon millions, billions of objects, which is another limitation that HDFS has. It's easier to manage, it's very resilient, it's much faster to restart if there is a failure. And as a result, you also have a much lower cost per terabyte because it's not just a storage density, there's also the operation and management that you can reduce your costs on.
Can I ask a question? I mean,
Please.
what we're seeing, we had a panel here just a moment ago, we're talking about these data wells where there's so much data in them that it's just too cumbersome to move it between platforms. Instead, you build up a new one and start populating it, and then you just let this one sort of die out. But imagine you're a telco and you have OpenShift, or maybe you have stuff in the cloud on Azure Blob or something like that. Is it possible to interoperate? Do you have to move it over to Ozone, or can you read from those storage areas as well? How is the interoperability?
I'll come to just that in the next slide.
All right.
Because as I do my comparison with HDFS, we're not talking about the storage density rather than 100 terabytes per node, 400 terabytes, the scalability, the billions of objects versus millions, the startup and recovery, active. This last element here, that's important. Because for HDFS, you have the Hadoop API, but when it comes to Ozone, you have not just the Hadoop API, you also have the S3 compatibility. So that way, you can use it in so many different ways.
Right, so as long as you're storing your stuff with an S3 compatible API, you're good to go.
Exactly.
Nice.
Which is also one of the reasons why, of course, Ozone is so attractive for many organizations.
Right, and that's because in true data lake or lakehouse fashion, they are decoupled in a way that's actually decoupled, so that when you do storage access, given that it's using S3 as an access protocol, it doesn't necessarily have to be your S3. It could be, you know, a blob storage somewhere or whatever is S3 compatible. They could access.
And that way you can move your data as and when needed. You can let one well dry out and the other one fill up again.
Right.
Exactly the scenario you just painted.
Okay.
Right. So that's on Ozone. But then the last thing. So, okay, we can do these data lakehouses, we can do them in public cloud, we can do them in private cloud, we can do them anywhere. But how do you make sure that this complexity actually always works best? That is the last element that I want to talk about. And there is a tool that we have in Cloudera's toolkit, which is called Workload XM, Workload Experience Manager.
Okay.
Because if you think about workloads, deployments of platforms, deployments of data across hybrid cloud, there are many different moving parts. There are so many different services, cogs, operational resources that are allocated. How do you keep track of that? It's a big challenge for an organization, and it sucks up an awful lot of resource. But not only that, how do you allocate resource and cost resources to, for example, a use case or to a team? That's an accounting exercise. Yeah. And as you no doubt have heard, more and more organizations becoming very conscious about financial governance around their operational systems. This is something that you need to get a handle on as well. But then lastly, in such a complex system, if something goes wrong, if a query doesn't perform today like it did yesterday, how do you find out what the root cause for that is? That takes a long time as well. You need to go through many different logs. You need to look at many different statistics. It sounds like an octopus would be really good at something like that, right?
Right.
Okay, how do you address these challenges? Well, we address these challenges with Workload Manager, because it gathers the telemetry, it gathers the operational insight of anything that is happening and going on in your deployed estate, in your lakehouse. It analyzes that data, it allows you to do monitoring, and allows you to do analytics from a historical perspective. You can start to predict the future requirements that you have, but it also recognizes when things aren't working the way that they should, why that query is running slower. Yeah. And here is our suggestion based on our experience, our combined experience from support, from engineering, professional services, on how you actually make this better.
Right.
But ultimately, it lets you manage that whole estate. So this is something where you can put a price on resources consumed by your workload and allocate them to a cost center. So you get a grip on not just the current cost, but also can start to plan for future cost. Now, doing that, it gives you tremendous benefits. There is improved use of your resources. You effectively, you find that you have free capacity, and you can do other things with it. You can run more analytics to get more insight and value from your data. You can make sure, because the system knows how much capacity is needed, it can automatically scale up, automatically scale down. You can adhere to your SLAs and SLOs so that your business users, when they do need the insight, they get them exactly when they need it.
Yeah.
But then also, if things do go wrong, you're 50 times faster at just finding that root cause. Found the root cause, now you can do something about it. And there is no more tracking logs, tracing logs, and so on. So,
well, I mean, there's something to be said about, I was trying to sneak a peek here at some of the advice that was given to what kind of errors you could get.
Yeah.
It's pretty cool to be able to track performance issues and that kind of stuff. And that relates to the cost of the system, but just being able to map out the cost is something that I don't think a lot of people consider and understand how much potential it brings. So one of the coolest features that I liked about Azure, because it was very early with it, was the ability to, first of all, separate subscriptions so that one cost center is associated with one subscription,
Yep.
and the other clouds hadn't really caught up with that.
Yep.
And it was really nice because it was very evident that you're spending all the money for your utilization. And I know there are a lot of tools that let you do sort of data platform stuff, but the cost management part is important to me, the way it's done here, because you want your data science projects to be justified by the value that they're going to produce outwards.
Yep.
So this is a cash flow issue, right? You have a resource that's costing you money,
Yep.
and there is no tech debt as long as your cash flow is positive.
Yep, that is absolutely
You can always
the case.
improve the margins and make it more efficient
Sure.
by troubleshooting it.
Yep.
But this cost calculation always has to be there.
Yep.
And the fact that you guys have a tool for that, I think, is very cool.
We do have a tool for it, and I've got something more on that later. But just to come back to what we set out, right? How do you build a better data lakehouse? Well, you build a better data lakehouse by making sure that it deals with any analytics on any data, and we do that through Iceberg as part of our platform. We make it work everywhere, or rather, we provide the equivalent capability on premises as you would have in public cloud through Ozone. And then finally, and I don't think you find many tools that are out there, we make it always work best. The best possible it can be, the optimal use of resources. So this is what we do in our platform, and this is how we innovate. But there is one kicker. There is something I can't quite talk about it until we get to the middle of June. Okay. So I'd like to invite the audience, I'd like to invite them to register now for our Cloudera Now event happening on the 14th of June. where I'll be able to talk a little bit more about the evolution of this workload XM that we just spoke about.
All right.
Moving in the direction of observability.
Is workload XM and the future of that, would you say that's central to a lot of the value proposition that's sort of being pushed forward right now?
I think it is a next iteration for not just Cloudera, but for many organizations. We know we can do data, we know we can do analytics, we can do it at scale. Yeah, some of them can do it a bit faster than others, but how do you do it more efficient?
Right.
The next iteration of efficiency for organizations in speed, in cost savings. So yeah, observability, applied observability is the next big thing, and we've got some great news coming up on that.
I happen actually to have gotten a sneak peek, or maybe some hints at which direction things are headed in, and so I think this is going to be a pretty fun event, so I urge you all to log in and check it out. I want to hear your opinions on, you mentioned that cost management is a thing, and we were talking at a panel here before about how much should be done within the, let's say, the platform management group, and how much responsibility should be pushed out to the organizations. And normally, when you're doing things as a group, you notice that there are scale benefits to centralizing things. So it starts off distributed, and then you're like, well, we're all printing paper. Why don't we get a printer together, and then, right?
Yeah.
But for some reason here with IT, a lot of times things are done the opposite. You get something, and then you try to get people reasons to use the centralized resource.
Yeah.
How do you see that dynamic playing out right now, and what role does Cloudera play in the push outwards or pull inwards that's happening right now in data platforms?
So not just talking about this innovation that we have here, but talking more about applying the platform. There are some great paradigms in that, and I'm specifically thinking about a data mesh, where organizations, as you say, traditionally, IT has centralized things, and the business lines of business have come to IT and said, have you got? We want to split that, we want to decentralize it, we want to pull it apart, we want to make individual domains the experts of the data, we want to give them the ability, but also the responsibility to do what they do best, which is work with their data, provide their data as a product. It allows the organization as a whole to be an awful lot more agile and flexible, and get to data insight and value faster. But here is the thing, it needs to be the platform that IT provides to support that. Which is why when I look at what are some of the key principles for success in doing that inside an organization, you need to be aware of the changing landscape. You need to be aware of this needs to happen in a hybrid infrastructure. Not hybrid infrastructure I'm aware of, I've got public cloud and private cloud, but hybrid infrastructure as in how can I capitalize, how can I take advantage of that capability? You need to be aware of these modern data architectures, these paradigms, blueprints, and accelerators.
Right.
And you can't just pick one, because if I say I'm going to build a data mesh, I need to get my data in somewhere. That's a data fabric, and I need to give the domains the ability to analyze and create that data product. That's probably a data lakehouse. So you can't just say I'll pick the best data fabric, because you need a data fabric and a data lakehouse and a data mesh.
Right.
So how do you, what are the characteristics of the technology that support all of those?
Yeah.
And you need to do that in the context of rising security and compliance.
Yeah.
You need to be able to meet, as a multinational organization especially, you're not just dealing with one single nation, you're dealing with countries the world over that all have different approaches. How do you tackle that? So look at these three elements to be able to go to that decentralization with a data mesh, and let IT be the heroes that say, we know what to look for in a platform from a technology perspective that meets the needs for all of you.
Right.
And then you realize you got Cloudera.
It's good to have one tool that can handle a lot of that stuff, or all of it, because last year data mesh was the word of the year.
Yeah.
Everybody was talking about it. Nobody really wanted to admit that data mesh had a technology aspect to it. They were saying it's all about governance, it's about people, it's about love, flowers, and trees. But this is a tech conference, and at the end of the day, it has to hit the ground.
Yeah.
And there needs to be infrastructure to support that paradigm.
And the key word there is support. A data mesh, indeed, it's not a technology solution. You can't go out and say, I'll have 3 data meshes, please.
Yeah.
But technology needs to support it.
Yeah.
There are the four key principles: decentralization, data as a product, self-serve access to infrastructure and analytics, and the ability to have federated governance.
Yeah.
Well, that's not one product, but there are products that support all of these elements.
Right. All right. This has been a really nice explanation. Cloudera, one of the OGs of big data, I'd say.
Thank you.
And still fighting hard, still some cool developments to keep track of. I urge you all to log on and check this out. Thank you for showing us. And thanks everybody for joining. We'll be back after a little break and looking forward to seeing you again very soon. Thank you.
Thank you.
Hey everyone, and welcome back. Data Innovation Summit 2023. We're at the last panel of the event, but I think the most exciting one. We're going to be talking about important, non-technical things. Maybe it will get technical. Depends if there's system support for the types of things we're discussing. But nevertheless, very important things. And so I have a panel of esteemed subject matter experts. Why don't we start off by introducing ourselves?
Thank you. My name is Marianne Lees. I am head of data analytics self-service at Ericsson, joining 3 years. So very much into networks and previously into private equity. But we see the common theme of data and AI. It's the same, right?
It touches
it's
all domains?
Industries. Yeah. It's
all right.
So very happy to be here.
Cool.
And hi, everyone. My name is Sala Francean. I'm currently the Vice President of Data Analytics for the customer and physical meeting points domains in IKEA, Inca Retail, Inca Digital. And I have a background as a mathematician, completely not applicable, very theoretical math. And then I've worked in finance for 12 years. And I've been at IKEA for a year and a half. And it's super fun.
All right.
Hi, I'm Sean. I work for Data Lakehouses, AI platform company. Background as a data scientist and a data science team leader. And my current job title is Field CDO.
Field CEO.
Yeah. CDO.
CDO.
CDO. They pay me to worry about the things that...
Is there a back office CDO?
I wish. I have to do all the work.
And is D data or digital?
I wish it was digital. It's data. I wish.
So the title of this panel here is Beyond Machine Learning Models, How to Build Capabilities and a Culture that Embraces Data and AI. And I'm sure we all have our battlefield battles on trying to, let other people see what it is that we see, the positive potential in data and in algorithms and data-driven decision-making. I'm just going to kick it off with a question from the audience, and I think we'll see sort of where it heads. But people are asking, what are the biggest challenges organizations face in building a data-driven culture that supports the adoption and implementation of AI technologies? And I will qualify that question a little bit. Does that transformation happen bottom up or top down? And you're not allowed to say it depends or both or anything.
Love it. Pick a side.
What do you say?
I think there's 3 types of challenges here, and usually people focus on one, and it's more like purely culture. But we have issues with culture, we have technical issues as well. So I think it's important to differentiate. So some of them regarding to transformation, of course. I think when we talk about data strategy, or becoming a data-driven company, or becoming AI-driven, we forget that it's not just technology that we're talking about. We're talking about probably the most impactful transformation in the organizations and in our day-to-day since a very long time, right? So, of course, there's fear. I think that's fair to say, fear from the unknown, fear of losing jobs. And so this lack of trust clearly impacts, I would say. Then we have data-specific challenges, and specific for us, we see issues with data quality. I don't know if you have seen it. It's very specific, very specific, very unique.
Perfect.
Very unique. And then, of course, data literacy, right? If we don't invest in data literacy, and I think we're going to talk a lot about that today, we'll see how hard it is to actually build a data culture that is not just high-level, fluffy strategy, but actually has some execution and traction in the ground.
Okay.
And then you have, from a technical point of view, the integrations that are needed, the compliance issues, and so on. So I would say three areas of challenges.
Okay,
maybe.
but top-down or bottom-up then?
Without leadership commitment, I don't think you can build a culture. To be honest,
this is good. I think
I don't think so.
We're going to say that. Well, this is like a little vote here. What do you say, Sala?
It does actually depend on the culture of the company. I would say where I am right now, probably the bottom-up initiation has been quite successful. So having like pockets of super smart people getting frustrated, not understanding why we aren't looking at the data, and then empowering them to actually start building data products and start looking at it and sharing really important insights. And I can see, like, just the last years, I have a super talented leader for our selling and payments DNA organization. And what she did when she came in was that she started recruiting data engineers. They started building really good data products in the PEDX team, so product engineering data experience. And now that's starting to completely revolutionize how people take decisions. Having access to that data and being able to see kind of what kind of transactions our customers are doing is, of course, a very valuable source of information.
Right.
And I don't think that like the top layer management would ever like take the time to think about, okay, so what kind of data products do we actually need? It's more like that needs to come from the bottom, but then the sponsorship is great to have from the top.
Do you
like
differentiate between data products and AI products and different kinds of products like that? Is that a meaningful distinction?
Well, I think data products are the foundation, and you can have like a very small data product, but build a really powerful AI product on top of it. Okay. Or you can have like a really good foundation, but very little AI. Or you can have a lot of AI, but the AI is kind of not so good because the foundation isn't there.
Okay.
And I think when you start building, like especially in big organizations that have been around for a while, you may have some legacy. I don't know. That happens.
No.
And in order to be able to kind of tackle it, it is a challenge because you have to modernize the legacy, you have to start building the data products, and you need to start building value from those data products. And sometimes it can be just like increasing data literacy so that people start using the information and building insights. And sometimes it can be like super advanced machine learning, but that's not so often. Usually it's just linear regression or dashboard, and that's where you get the initial massive value and also the buy-in, and that is super important.
But like, okay, I think this is going to be controversial. I want to hear your opinion. So let's pin one thing here in terms of the, I guess, and this is also going to be on the bottom up or top down. So I want to get your answer on that first, and then we move on. But it seems that there are sort of caps on the amount of value that you can derive depending on how you do things. So you mentioned the complexity of the model and the AI systems that you use. I also think that whether you start top down or bottom up, there are also caps. So top down or bottom up, which one is ideal?
From the side.
From the side. That's a cop-out. All right, we'll save it. We'll ask it again later.
That's an innovative approach.
Yeah.
See, right here, importance of innovation.
All right,
exactly.
Yeah.
What do you say? Bottom up.
Bottom up.
And I think that's partly just my own experience of any change that I created. Even if I eventually helped get top-down sponsorship, it doesn't materialize out of a vacuum, right? You need to create pressure, create value, demonstrate something, and then get it. So if I have to choose, and if I advise, we have mostly large enterprise customers, it needs to be bottom up, because without individuals like powering this, if it is just people from the top saying build this or build that, and they tend not to know what to say after that, it's just build more AI or data or something, and here's some money. Yeah. Maybe that reflects a relatively poor top-down sponsorship that I've experienced in my life, but especially this change and maybe what generative AI maybe helps us do in terms of lifting some of those caps that you were talking about in some unexpected ways. I think it has to come from the people doing the work on the ground.
Can I counter that just a little bit? And I think it's maybe what we are talking about, what is really a data culture, right? Because we all see pockets of competence and great work happening, from our data scientists. So we do have that. When I say the importance of leadership is without a clear data strategy, without the really investment, resourcing available, right? This you will still have pockets and you still have initiatives, but the right traction and to become strategic for a corporation without the leadership, I don't know.
But can you name an enterprise that's done that?
I would counter it on a purely theoretical level, and then whether this works or not is a different thing. I think it does work, but the fact is that if you start bottom up and you start, you can also think of it as like an AI that's bringing about marginal improvements, or perhaps taking an existing process and improving it. what you're really doing is improving your profit margins. On the other side, if you have something that affects the business model, you can potentially charge more or perhaps provide a new service or something that a customer will like
revenue
more.
streams.
That is uncapped. Your profit margins are capped by definition on their own.
Economic.
And I suppose what bothers me a lot is that we are preaching to the choir here a little bit, right? And what we don't have is necessarily C-level people or boards of directors that are thinking, what kinds of services could we even offer to our customers that are entirely data-driven or insights-driven that are so valuable that customers would be willing to pay more? So like in logistics, for example, same-day delivery. You can only do that if you're organized enough to be able to do that kind of real-time management of your fleet. Is a customer willing to pay more for real-time, for same-day delivery? Yeah, probably. Maybe even a lot.
Guaranteed window the next day.
Guaranteed windows, whatever, that kind of stuff. But that's a business model thing more than a a data scientist POC type thing in my mind.
Yes, I agree. But so one of the reasons why I wanted to join IKEA is that affordability is super high on the agenda.
Yeah.
So I mean, if we were to improve logistics, for instance, we wouldn't make it as a goal to sort of make the customer pay more.
Yeah.
We really want to be able to be there for the many people.
Yeah.
And so for us, improving logistics, optimizing processes, it's all about keeping costs down so that we don't have to increase the prices, so that we actually have the many people able to buy the products that we sell.
I would totally agree. I think cheaper and charging more is the same thing, basically. If your business model...
No, it's not.
From economics standpoint, making the Model T Ford cheaper is the same thing as giving people more money. So your business model is making people afford furniture.
Yeah.
And so if you're making a furniture that somebody wants to buy more of, or you're making it cheaper, it's pretty much the same side of the coin. In any case, if your approach is to lower the price of the furniture, that is very much aligned with the business model of IKEA.
Yes.
So, if everything points in that direction, I think that's a valid approach.
Yeah.
It's not clear to me. What I suspect is that in IKEA that mission is very expressed, very succinctly expressed. And in shipping companies, it's not clear to me what the goal of everything is. It's delivering packages, but do we charge more for delivering it on time? Do we charge more for being able to deliver it closer to the person's home? Do we charge more for being able to deliver heavier? Like there's a lot of gray zone where the question is, what is the true value of the service that we're offering? And when you have a goal that's as well expressed as the one that you mentioned for IKEA, it makes it very easy for everybody to have a culture where we're all aiming in the same direction.
Yeah, simplicity and cost consciousness are kind of two of the main values that IKEA lives by. And I think it does it changes a little bit what you're optimizing towards.
Right.
It's not necessarily making the customer, it's definitely not making the customer pay more.
Yeah.
It's allowing the customer to pay less.
Right.
To really
it's also a measurable
available.
thing.
Yeah.
So, here's a question then. Does the output have to be measurable?
Yes. What are you optimizing towards if it's not measurable?
I mean, I agree. I'm just trying to play my own devil's advocate here.
No.
Okay.
No, yeah, I was joking.
It has to be measurable?
Yes.
Okay.
Yeah.
All right. Well, then
I think we would agree on that.
Yeah. So, but actually, I'm a firm believer that you change what you are measuring. So what you're measuring will be what people are aiming towards. And I think spending the time to really think about whether you're measuring the right metrics can be absolutely like the game changer.
It is.
They can be more transformative on business models than any AI thing you might build.
Yes.
Just by actually heading towards the right target.
Defining the KPIs and consistently measuring it. But then again, we go back to the leadership, right? Who sets them up, right? Because if you say, we believe we want to have a data strategy, we want to be in the forefront, but then actually what you're measuring and what you give importance is completely different. It's not going to happen.
Well, we had a good question here earlier about setting up these measurement things, because it's not always evident that what you're measuring is what you actually want to achieve. And I think at the end of the day, you take sort of a gambit and you say, well, cheapo furniture is our business model, that's what we want to do, and we think that's going to work, and we think that's what people want, and so we're going to go for it. But somebody gave the example of showing relevant ads. And how do we measure that? Well, if they click on it, then it's relevant. Not clear that it's relevant just because somebody clicks on it. And so how easy or not, or how important is it to set those goals for the company?
I think that there's one misconception of what should be measured. And it's not because something is measurable that it should be a KPI or an OKR, right? I think that's very, very important to differentiate, because I think we've seen an era where we wanted to measure everything, how many clicks, how many forwards, how many comments, but we need to understand that, okay, you can have all that, but then it doesn't impact sales, for example, or it's not impacting. So
all those KPIs on one single dashboard, the great, can you just put all of the information on one page?
Exactly. Exactly. But then it doesn't give you anything, really, right? It's just that, but we can measure it, and then it seems very advanced, but it's not. So I think, yes, understanding the importance of having OKRs, and I think you were touching that, saying, even the ones you define today, they might change, right? As you progress, you might want to adapt and define new OKRs and new targets. That is really, really important, both on a business side, and of course that is revenue streams, that could be efficiency, productivity, cost savings, working capital, but also from a data perspective, like data literacy, for example. How many companies have that as an OKR, right? So I would say yes, important to measure.
It sounds like you're saying something like, rather than collecting everything, you should collect with intent. And it seems like some of that data needs to be designed in a sense, right? Because it doesn't exist, or it's not being instrumented, or we don't know exactly what we're looking for, and that you have to sort of create the circumstances for measuring the thing that you want to measure.
Yes, I think so. And I mean, sometimes it's about starting to collect data because you didn't do that before, because you didn't realize that this might actually be something that could be of value. Sometimes it's about creating the real metrics that you actually believe are the right ones for now, and then being very clear with these are going to change as we learn, as we progress, as we mature. And sometimes you just need to use a proxy, because it's not information that you're ever going to have. And then finding a good way of creating that proxy.
Can you talk about that more? I mean, because sometimes there's a time delay. You guys want to make cheap furniture, and sometimes even
high quality furniture.
High quality, affordable, and so on.
Thank you.
And if you do that correctly, maybe customer behavior even changes because of you achieving the goals that you've set out. And so there's a time delay, there's a long time before you can measure the effect of a thing that you've done. Proxy variables, is that a way to get there, and how do you think about that?
Yeah, so I mean, I work with my teams in the PEDX teams. They work with the web, the app, and the kind of digital touch points in the stores, both for coworkers and customers. And so it really depends on what it is we're trying to do. So it could be that we're trying to really engage with the customer to understand what their needs are and kind of inspire them or give them very succinct information. It could be that we've just rolled out like a new recommendation algorithm and we want to try out how good it is. And depending on what part of the journey we believe they are on, either we want them to convert, so they press and they buy and they're happy, or we just want to give them a lot of relevant information about, like, if you're looking at a kitchen, it might take a while for you to actually buy it, and you might want to speak to a human before you do that. And so the metrics need to depend on what kind of a journey you're on.
Yeah.
And when you start out, you probably just want to have how many people came to this website.
Yeah.
And if you don't start with that, then you're it's going to be really weird.
That entire design process for that data that you just outlined, though, is not something that a lot of people in the rest of this room learn as part of a data craft. They tend to need to get it from a business background, a product background, a real life background. And so what ends up happening in a lot of enterprises is, instead of data being designed for a purpose to track an outcome and improve it, it's basically found data, like found art. And let's
like a byproduct of operations that happens
just
to be
emissions. I had facilitated a panel at our conference last year, and someone introduced themselves as working in sanitation. Right?
Nice.
Which is like very funny and self-deprecating, but kind of like kind of encapsulates a lot of the problem, and a lot of the energy spent by a lot of people and vendors in this room is to try and just deal with that problem of, but what if we just went and designed the right data up front? Would everything downstream be a whole lot easier? And I think in many cases it would.
Well, is it necessary to, because now when you described like a recommender system, and it can be viewed in isolation, but but it could also be viewed as part of a customer life cycle journey. Yep. I don't know what the cool word for it is anymore, but we've been talking about the panes of glass and the life cycle.
Missions.
But,
the journey.
The journey of the customer.
The missions of the customer.
Can this be instrumented, or should it be, or is it instrumented all the way so that your recommender system did what it was supposed to do, but at the end of the day, it's not even a customer that has gotten great value, but somebody that's at home with the furniture and is happy and hasn't called support and blah, blah, blah. Like the whole thing.
Yeah. Yeah, I think what I've been really happy about working in customer domain is that we have an extremely talented, experienced design lead, and she's talking about life at home missions. She's drawn up these really sort of compelling customer journeys to kind of allow us to dream. So when you work in this kind of a digital company as I do, you need someone who helps you to dream. Because as a data scientist, I'm not very good at doing nice PowerPoints, etc. And I'm not good at design. So we really partner super close with our design experience people because they meet the customers, they do a lot of analysis, and then we from data can help them to validate whether they're sort of what the customers are saying can be validated in a more general context. And I found it super inspiring to really think about it from that perspective. Okay, so you want to buy a cup. Okay, so then here's a cup. Welcome, and you're probably quite happy with that. Or it's it's spring, I need to do something about my balcony, and it might be a bit a larger thing. So we've been really we have excellent people working on recommendations, both content, range, price, and they've kind of been really thinking about this because it means that you have to optimize towards several parameters, and you need to have much more of a flexible setup from a sort of more technical viewpoint.
How skilled is she in data science?
Who? She is, I would say she's very good at understanding what's easy to do and what's difficult to do.
Oh,
and
that's
that for me is the key. You don't have
knowing
to be a data
when you're
scientist.
about to get in trouble.
Yeah, or knowing that this is going to be a 3-year project and maybe the value's not there. Or okay, so this will probably take Sal and her team a couple of days, so let's do that.
Well, maybe she's gotten that because she's worked with you for a while, so she knows what to expect reasonably.
Yeah, she's a very smart person.
I mean, I feel like that's one thing that I'm good. I know how long I take to do certain amounts of work, and when I work with people, I tend to enjoy working more with people that imagine too much, and then I can pull them down, than people that can't imagine anything, and then I need to invent stuff about a domain that I have no clue about. Because it's easier for them to say, can AI do this? And I can be like, it's going to be a little bit tough. But it's really hard for me to say, oh, why don't you organize your car manufacturing? I have no idea about cars. So what kind of upskills do managers need to be working on immediately now to be working efficiently with their organization? If we're talking about going data-driven and that kind of stuff. So the C-levels and the up there, we're talking about upskilling, but what kinds of skills?
For leadership or
for leadership roles.
We actually started to put together a specific program for leadership where all the initiatives that we have, because I think maybe you have similar experience, maybe you have for sure, and that is even the good things that are happening on the ground before they can come to the leadership, radar and knowledge, so much is lost on the way that maybe they think, no, we're not doing it, but we are. So just creating this awareness, I think it's really, really important. So having regular sessions on what we are doing for, it could be lineage or regarding marketplace or strategy or whatever. So they actually know that this is happening.
Oh, so technical? Like you teach leadership about data lineage?
Yeah. Well, not like this is how you do it.
No, but still, even just the concept itself.
Yeah, but it's... Yeah, there are ways to do it, right? You don't do it the same way.
I'm not saying that it's not super important. The leaders that I know can barely, they don't know what. Like if I say binomial distribution, they'll.
But I think we also are seeing a new generation of leaders
yes,
as well.
Okay. Yeah,
and
that's
sometimes
fair.
not just in age, but mindset, right? It could be a young person with an old mindset.
Yeah.
So I would think that is definitely important that they are aware of what's happening. And then the second is the value that it brings. Because unless they understand that, they will not prioritize it as well. So I think it's quite important that they're not just dependent on 1,000 other people to know something about what's happening in their own company that is actually changing and the needle significantly, right? Moving the needle significantly. So a data literacy program for executives, I would definitely support.
We're seeing more of those. A lot of those are ground up, but some of them are targeted at executives as well. And it's even become part of my remit to basically mostly just demystify what is AI to those people. And we're using the moment of heightened public interest and maybe slightly suspended fear that generative AI publicity is giving to start offering this mostly to existing customers where we want to expand the use of Dataiku to just help people up the top understand from an outside perspective, look, some of this is very complicated. Some of it you can completely understand. And the powerful thing that we always sneak in is we talk about other companies in your industry that are doing stuff. I always put examples in there that are actually from the company, but then I reveal that later.
Okay.
Typically when they say, we're not ready for AI and we're not doing it, I say, well, actually, half those examples are your people building stuff right now. But point taken on the generational thing. And I think that, so we try to demystify people. There are certain leaders who are just not going to change how they make decisions, right? And all of this work, putting more data, more power out in the organization, out in domains, it
can have the opposite effect, actually.
It can have the opposite effect,
It could.
I have to ask, because otherwise I can't stop thinking about it. Why would you talk about binomial distributions when you're talking about data lineage?
Because it's a coin flip. No, not about data lineage.
Yeah.
It's just
so random. It's like,
no, it's just
my reaction was it's significantly above data lineage in terms of
No,
I really want to hear you talk about
I've
data
given an
lineage
example
now.
of an unfair coin to a decision maker, and that is the simplest statistical thing in the universe is an unfair coin, and I think that's way above the kind of stuff.
But data lineage is, I can imagine lots of metaphors that you use to help them.
Exactly.
But it's only because data lineage, when it comes to AI stuff, it ties into explainability and a bunch of other stuff. I know there's like the data warehouse data lineage aspect, but and sure.
But that's the hard work. That's the hard work the executive needs to understand. They don't really need to understand the distributions. They need to understand the cost.
And we are in a journey for simplification, also in our system landscape, again, legacy, for those who have encountered that. So that is very easy to show. For example, if you're looking for the single source of truth of data, and then suddenly you have these scattered systems, right? And the time that it takes to understand where is data coming from, who owns it. So there are ways to do that. I think from a self-service perspective that I'm coming from, it's all about not how do you enable or empower the engineers and the scientists, but really, the business people, how to use data and analytics in a very self-sufficient, confident, feeling empowered, data-driven, but also value-driven results. So
and I think because for me, having worked in slightly large organizations, it's all about managing expectations. And so at SEB, when I was still working there, we did this really fun exercise with our the higher management, where we printed out a page with I think 20 columns, 10 rows, and names, postal addresses, tax addresses, with perfect data. And then we asked them to pick the customers that were located in Stockholm that would be relevant for a specific campaign. And it was so good because they started having those important discussions about, okay, so is it the postal address or is it the tax address? And it is, data quality and working with data, it requires skills. And I heard, I'm not completely objective because it was a Finnish person from Yle, the Finnish broadcasting company. And he was saying that when they started their data strategy, they first talked to the stakeholders and asked, what do you need? And then they started hiring not data stewards, but responsible analysts. And I just love that name because I've been trying data detective, just analyst, because you're actually working with the data, but responsible analyst, I like that because it makes it clear that this is a very highly qualified job. It's super difficult.
Not a leftover,
No, it's not like bring in a junior and let them fiddle around.
Clean the data,
it's really finding the people that are passionate about the data that they're working on.
And making sense out of data, right? Yes. I think it's not nothing, right?
No. So I think there are ways that you can make it into like a bit of a fun game and also at the same time illustrate that some parts are difficult and they take time and it is sort of annoying. But there are things that you can do in the meanwhile. Like you can use this for marketing or you can use this for softer things. And then as you progress, maybe at the end you can have like, I don't know, AI for finance.
Yeah.
But everyone's far away from that. There's no one that could do that today.
But okay, let's argue about this because I think it's always more fun to watch people argue. Maybe this is hypothetical exercise here. What's reasonable to expect a leadership team to learn and that kind of stuff? I'm trying to think of, let's say you're doing customer segmentation, and to your example of or whether it's data lineage or whatever, I feel like it's more reasonable to expect a leadership group to understand the principle of that you can cluster customers, and don't worry exactly how that algorithm works. It will tell you how many customer segments that are distinct with a certain confidence level, and then given that information, you can make an informed decision. But sort of having them have, I'm not saying this is what you're suggesting, but like having them sort of understand exactly how hard it is to decide which customer to run a campaign on or how they should be segmented. I just don't think they have the tools for that. It's better to let like an analyst do that kind of stuff and let the CEO not be in the dark, but understand more the principles of the outputs rather than the methods of the input somehow. What do you?
So the reason why we wanted to do that exercise was that we wanted to do proper expectation management.
Okay, yeah.
Because they were getting really like, oh, but why don't we have good customer data? We should just do it, And we were like, we are doing it.
Okay.
But it's going to take some time.
Yeah.
And this is what our people are doing.
Yeah.
And then, of course, you can use machine learning and stuff to sort of quicken up the process, and you can do a lot of smart things to improve on the quality, like for the future.
But expectations is good. Maybe that's a word that
Yeah, I think
we can
you said that too.
Yeah.
It's our common.
I was going to say, great idea.
So expectations on what? On how long things will take, on
and
outputs?
The complexity.
And the complexity.
I think the complexity, and the other thing is the interdependency of things, right? You cannot not care about your data platform, but then demand that the output or the end result should be there, immediately, and fresh data and reusability, and so I think. Yeah, expectations on the complexity and the interdependency of things. I think it's quite important that they are aware, but not all, that how hard it is and what kind of validation or preparation. No, not at this level. I don't think any of us.
So they understand the scale of investment, but also the path of investment that you're proposing. Because if you just use that to kind of build up the scale of the investment and ask for lots of money, then they'll give you lots of money all in one go and then expect a lot of stuff almost immediately. And so typically what the expectation management we have to do as a vendor is over time you'll get this value, and yes, it will cost you a lot of money to get that value, but don't start there. Don't start with the big bang. Everything you've ever tried to do about building stuff, don't do it that way. Start with these small things.
Incremental.
That's often harder for leadership to get their head around, that they should start with small investments that accumulate and help the next investment pay off. It sounds really good to me as I say it, but that's often a little bit unfamiliar to people who are, honestly, compared to what's spent on the tools in this room, they're used to spending so much more on other things. So sometimes I also wonder, do we make it sound too small and feasible and easy compared to how much money and time and resources they shove at other parts of the business?
That might be a good indicator. What's the percentage of your budget that actually is going into, data-driven initiatives or AI-driven initiatives?
Not a bad measure.
That would be interesting.
But I have this kind of pet peeve when it comes to building like data analytics organizations and products and things. In every part of IT, everybody's talking about microservices. So we want to build small things that we can launch and then scale and maintain and then kill and do proper lifecycle management. And DNA is still, like data analytics is still so immature that I think a lot of, especially smaller companies, they don't really have the money to have these like vast skilled sets of people that are building the data analytics. They end up buying monoliths and then they're stuck. And so it really reminds me of like the beginning of the internet when people were building monolith websites. And then you're like, oh, we need to change this part of the website. Okay, we have to wait till next year. It'll be fine.
Change everything to change that one thing.
Yeah. So I think, like for me, I'm a super fan of open source. I'm sorry. Super fan of open source. Super fan of building small, scalable things that you can then you start small, you learn, you add new data sets, and you use that to inform your data strategy as well. So you don't start with like building the perfect data foundation with every single data point you have. But you actually start with where is the value? What is it our customers need? What does our stakeholders need? How can we start there?
This is a recurring theme in these panels, and I was going to shove this theme into this discussion, but you brought it up, so here we are. What about technical debt? We've been talking. Okay, this is something I've been saying, and I think I've gotten a lot of sort of response on it. People agree that if you don't have to install the Titanic to do your project and realize the value of that project, and that you sort of need to justify this platform one piece at a time. You don't have to do data. You don't have to have the platform to do data science. And this is where I can cast shade on the IT folk. Finally, it's mostly the people, but in this case, it's the engineers that are always complaining about technical debt. And I don't think technical debt really is an issue. If you have something that's generating money, it might eat into your margins, and you might want to do things more efficiently. And so you should redesign it the right way, but as long as the value is justified ahead of time. Because that's the problem. If you make a project where you start spending money and then it's a POC, a proof of a concept that maybe this is valuable, and then it's not valuable, but you're already burning money, then you're in trouble. So what is your take on because the management and the data, the people aren't worrying about technical debt, but that is the only thing IT people are saying. We have to do it the right way. We have to set up this platform and everything. What is your sense of whether there's truth to that or not?
I think that things that are working and generating value, keep them going. I think to your point about the monolith, what scares the shit out of data people and keeps them up at night and gets them talking about technical debt is when, and to your point about dependencies, when there's something that has been around a long time that is no longer generating value, but lots of other things depend on that thing to generate value, and then the benefit of the thing is getting divorced from the maintenance cost of that core component or that one mapping spreadsheet in the middle of everything.
Great reflection.
And so it's, I have a credit card. I don't mind having debt as long as I have a plan to pay it off, right? And it's useful to me. When people get into trouble with personal debt is when they're using one bucket of debt to finance another one, and then they get underwater very quickly, and it's still a little easy for that to happen in data land. That might be why we talk about it so much.
Is this a new concept? I'm thinking in like complex car manufacturing or IKEA, or where you have chains of dependencies like that, and there has to be physical technical debt somehow that is equivalent. How do you manage those kinds of
so I'm not
rationalizations?
I'm not responsible for engineering, and I'm not even an engineer. I'm a mathematician.
Okay.
But I can try to give you some sort of an answer. Just from like my aggregate experience from working in enterprises, I think what was happening until maybe the 2000s was that tech wasn't changing that quickly necessarily. So you had companies that were quite comfortable sort of running the 1-year upgrade for the systems that they'd had since the 70s. Everything was super stable, very robust. And then we started like the iPhone, they came cloud, loads of new tech and opportunities. And then companies started to a little bit panic that they were going to get left out. So they invested in these massive transformation projects and tended to not maybe always complete them completely because it's way too challenging. And so I think now with kind of this agile way of working, transforming to more of a sort of microservice DevOps perspective, at least it starts to take care of the problem, but it's still going to be there for probably 10 or 24 years. And after that, we'll probably have a problem with DevOps being obsolete or something, I don't know.
We will have just caught up, and that's already not cool anymore.
And I think, but I mean, just this is completely off topic, but I think what I'm excited about when it comes to like large language models and the latest sort of hype is that I actually think it's going to make programming easier. and it's hopefully going to make it more stable and more
For who?
robust for programmers.
For experts or for noobs?
Yep,
or?
experts.
Yeah.
Yep. Yeah, because noobs, then you don't know what it's created, and you're like, I hope it's okay.
Well, I mean, I had a friend that I think they installed AutoGPT, and this person doesn't know any programming, and they generated a website. They made tons of stuff, and I thought it was very cool.
Yeah,
and then you have me, and ChatGPT is cheating for me and helping me debug stuff and everything, and I think it's amazing, and Copilot too.
Yeah, my colleague asked it to build an algorithm, and it wasn't great.
No, but it's like having a friend on the phone that can't see your screen, but you can ask for advice. That's how I see
so
it.
weird limitations and no accountability.
Yeah.
Exactly.
Right? So if you
told me to
use
do
it
it.
like that, then it's fine. Yeah.
And you forget you have an NDA, so you tell them all about the new product that's going to come out and everything. Yeah. What do you think about technical debt then? I really like this. It's not generating value anymore, but you have other things that are generating value, but we don't.
That depends.
We don't
Not
make
very
a
good
map.
at transferring value and cost between different parts of a data product stack.
Yeah, but we don't have a method, or at least that I know of, that's very popular for rationalizing costs in a cost lineage way. Right?
We do.
We are doing that more and more, right? I think we are doing that more and more. Even when we have systems in capacity mode, we are trying to find a way to charge back to those who consume it, right? In the same proportion. So I think we're very much going into that direction. I can tell you from self-service, we have maybe 80% of everything we have today, which is around 10 different products, for example, serving 40,000 people at Ericsson. 80% should be in chargeback. So it is possible to do, but I think this value approach is quite recent, that everything, moving from being a cost center to a value center is quite new. So we're starting to do that. I think your point is really spot on. What exactly qualifies as technical debt?
Yeah.
Right? What is that? Is that because no one uses it? Because it could be, and we are, at least in our company, we're very good at onboarding new systems. We're not as good as closing them, right? So sometimes, yes, there could be dependencies, and then there's not really depth there. It's just the way you calculate the value is separated from the cost. But in other cases, what you see is that you're very eager, okay, what's the next one? So, for example, this year, one of my OKRs is how many systems we're closing.
Nice.
Yeah. I'm measuring literally. Right? Yeah.
One of my bosses, the moment I knew I really wanted to work for her was when she said, I knew that if I asked people, do you still want these reports out of this old thing, they'd all say yes, yes, yes. So I engineered an outage. She engineered an outage.
Yeah. Nice.
Yeah, but
and then waited to see who
we have done
woke
a similar thing as well. We asked, and everyone said, no, we need it. To say, okay, then we just move them.
Oh, but we just stopped sending them, and then we waited to see who reacted.
Who's going to react? We had one.
We had
Rebuild those ones,
150
and then you
reports. It was just one.
Yeah, we had the same. We moved, and
I heard the most genius suggestion ever almost a year ago now, and it was a woman that works at Telia who was a boss of a large organization, and we were talking about whether or not you can automate certain roles, and she has lots of direct reports. And she was saying that, if you ask any of her engineers how easy it would be to automate what they do, they say, well, I just do so many things. It's basically impossible to automate what I do. And then she was like, okay, cool. I'll give you a year off and a raise if you can automate. And then they started getting so creative. They're like, actually, it is a couple of things, but I think I can do at least 90% with this shell script, and then the rest I'll do, Okay, so when it comes to sort of creative, weird stuff, LLMs is all the rage. We've actually mentioned it in this. We have about a minute left. I want to hear your sense of, is it just a cool chatbot, or is there something to it that's going to fundamentally change the way we work? Is this a new paradigm shift, yes or no? What do you say?
Yes, but not in the ways that people think it's going to be today.
Okay, moderate. What do you say?
Yes, in ways that we want, and also all kinds of unexpected ways.
Unpredictable ways. Yeah. On the whole, good or bad?
I'm incredibly more positive about it. Six months ago, I thought it was just about generating art, images, and stuff. And now I'm starting to see what people are doing, and I'm starting to see this creativity, especially about people changing their own job. And when people start changing their own job and upgrading their own job, that's just a really powerful thing in human
That's
history.
really neat. I think everybody should feel like it's possible for them to try this out and get a sense of it themselves. What do you say? Is it hype or is it substance?
I agree. I think it is going to change the way we work, but in many ways different than what people expect. I totally agree. We're actually quite aligned here. Next time we need to.
I know.
This is the
We were
good.
trying to
get
be
us fighting, but we
confrontational, we can't seem to find a way.
We couldn't even fight about technical debt. Yeah.
Yeah, exactly.
So maybe there's not quite as much outrage as Aftonbladet and all these magazines wanted to seem like. Well, positive outlook, and there's a lot of work to do,
sure.
and it's going to turn out good if we put our minds to it. All right. Thanks, everybody, for joining. This panel went really quickly and was the most pleasant and fun one so far.
That's us.
Excellent. All right.
Thank
well,
you.
join us shortly for another interesting session. I'll see you soon. Thanks, everyone.
Thank you.
Welcome back to another expert session / product review. This time I am joined by HP. Please introduce yourself.
Hi, which camera?
Yeah, anyone.
Anyone. Hi, I'm Alex Klug. I work at HP as a product development manager, focused on data science solutions. So it's my job to look at and see what are some of the unsolved pain points in the industry, specifically when dealing with local compute, obviously what we produce, and try to create new software solutions that kind of help fix those problems.
So data science specialized, huh?
Yeah, a little bit. Yeah.
I have a couple of HP workstations, and I find them very useful, despite that we're in the cloud era.
Yep.
And I think some people think that, it was really funny when I worked at Microsoft, people used to talk about the post-PC era.
Yeah.
Do you remember that?
Yeah.
Ha ha, Forrester and everybody that thought they knew what they were talking about. Anyway, we're not post-PC, I don't think. But, so you're data science specialized, and I guess the cool thing is there's an implication that the workstations are used in many domains, not only data science.
Yes.
So what domains are they used in that's not data science, before we get to data science, and why that's become a specialization now?
Yeah, so I mean, traditionally, like media and entertainment is a main use case for us. Architecture, engineering, design is a big use case. Product development, so a lot of traditional. We actually, won multiple Emmys and Oscars for our workstation solutions.
Okay.
Supporting like Pixar films, for instance, DreamWorks, animation, a lot of renderings done. So that's a big use case. But obviously, anyone who requires within their workflow high performance machines are who we're going after. And so more and more these days, that's data science and AI. And so a couple years back, we kind of noticed that trend, and we're like, hey, we're seeing this demand, we're seeing these opportunities. How can we kind of invest and take advantage of that in this growing field? So luckily, we maybe we're a little bit more prescient about it than others, and started investing in that, and we're continuing to do so. So what's really cool being at HP is like my team specifically focused on solving those problems for data scientists and looking and seeing how we can make these solutions even better for them.
Yeah. Well, it's funny to me because I think for quite a few years now, when I've been thinking about, what applications there are for super powerful machines, scientific computing immediately, comes to mind for me. I guess the main issue is that it wasn't such a common practice.
Yeah.
There weren't as many data scientists.
Yeah.
But now, applying AI, language models, and that kind of stuff is ready at hand. First of all, it's easier.
Yeah.
And so your machines are, very useful tools in that endeavor.
Yeah.
So, tell me, there's more to it than just machines, though, right? Because you're not just focusing on machines. Although I think we can talk about them as two separate subjects. But there's machines and there's software as well.
Yeah.
What can you say about the software that's part of the data science initiative?
Yeah, sure. So absolutely. So as kind of the use case came to be for HP and customers demanding, high performance machines, we're saying like, hey, great, we produce those already. Here you go work with them. They're like, whoa, hey, like all of our tools and systems are built to support the cloud. We don't have the ability it's not easy to work in locally. So more and more we're looking at how can we enable that local compute for data scientists, make it easier. So one of the first software solutions that we've come out with is our data science stack manager. So really it's like, hey, you have your machine, but it takes a while to get your environment set up. I need to bring in all my tools and packages into this environment. I have compatibility issues with my drivers. It's a pain to manage. For some people, it's not too bad. For others, especially if you're not super technical, could take weeks to get set up. So we created a simple software solution that enables you to do it in minutes. And then really kind of going forward, it's like, what's the next step and what's the next thing that we can solve? So there's stuff in the pipeline what we're really excited for, hopefully next year to be able to present about really enabling people to connect their workflows where they're working locally, like you talked about, because a lot of things start locally, or if they're scaling all the way up to the cloud, just giving them the platform to do all those things together.
That's neat. I think there's stratas of focus when it comes to data science. I was talking to some university group that just wanted to get going with GPU programming, but didn't want to manage the machine. They just wanted an environment. They wanted PyTorch, CuPy, and a couple of other things installed. They didn't want to check which version of CUDA was installed. I guess we're not talking about Vulkan so much and those kinds of like really low-level stuff, because I guess one of the things that I know HP has been talking about is WSL, Windows, or Ubuntu, and that you can switch between them or choose whatever suits you best. In a lot of corporate environments, Windows is very manageable.
Yes.
So what have customers been telling you about sort of their preferences in that respect?
Yeah, well, it's really kind of an awareness issue. A lot of people don't know about WSL2, which is
that's surprising to me. I feel like that's one of the main features of Windows 11 and 10 that
yeah, we've worked really closely with Microsoft to enable that and to push it out. But obviously, what's the benefits of Windows, like you talked about from an IT security standpoint? I have all my systems and tools built around that.
Yeah.
From a productivity standpoint, it's really easy to use. But then from a data science perspective, like I want to work in Linux. So how do I do that? WSL2 is just a great way to work within Windows in a Linux environment.
Yeah.
Yeah, but a lot of people don't know about it, which is
well, I mean, so for the people that don't know, Windows is actually, there's great things about Windows and Linux. Trust me, I've been a kernel developer. I'm not even a Linux person. There's an old joke that used to be, people that run BSD do it because they like Unix, and people that run Linux do it because they hate Microsoft.
Yeah.
Okay, so Windows actually has the ability to have multiple ABIs in parallel so that it could support OS2 Warp, POSIX, and multiple. And so WSL1 was a way of exposing the WSL user space sort of interface to the kernel. But WSL2 is an actual Linux kernel running in user space on Windows.
Yep.
And what they've done in Windows 11 is really accelerated. So disk access, network access, and a bunch of other things is not native speed, but good enough for development purposes.
Yeah, absolutely.
It's very pleasant to develop on a WSL2 environment locally. The only thing I found doesn't work is Vulkan stuff. So if you guys are going to try and do video games, I guess that'll be a little tough. But Torch and all your regular ML tools work in WSL2.
Yeah, and that's exactly what we're doing when we're using our Stack Manager. We're bringing it in through WSL2 to create that environment.
All right. Okay, so let's talk about hardware. And let's separate it into mobile workstations and workstations.
Yeah.
Tell me about HP's workstation lineup.
Sure.
There are tiers of ability and what's at the top so that people know.
Yeah, absolutely. So we have a number of different platforms within our mobile and desktop workstations. Kind of starting at mobile, and at the lowest tiers are Firefly. It's lightweight, but still high performance. If you're doing probably a lot of data analysis, visualization might be good for you, especially if you're really mobile. Moving up, you have your Studio and Power platforms, and then you have our ZBook Fury, which is a high performance.
The thickie.
Yeah, it's a thickie. It's a big boy for decent compute, of course. And then on the workstation side.
But what's the difference between a workstation laptop and a regular laptop then?
Sure, it's the quality of the GPU and the CPUs, right? So you have enterprise grade CPUs and GPUs, just on a higher performance spectrum.
Right, because there's Quadro GPUs in the Fury.
Yes.
And it's a Xeon also.
Yeah.
I think it even has ECC memory or something, right, on the
Fury?
Fury?
I believe so. Yeah. And our G10, our Generation 10's coming out in the next couple months.
I mean, one thing that struck me about the Fury, and so I have the ZBook.
Okay.
And the Studio, ZBook Studio.
Okay.
Which is the best one you can get that's not a thickie.
Yeah.
And the thing that matters to me, it has lots of other cool stuff like RGB keyboards and a nice screen and whatever, and a good GPU. But really, it's that the fan and the cooling on it is so huge.
Yeah.
So I run heavy stuff on it, and it gets really hot. And I used to have this old laptop that I really liked. I'm not biased. I can like many laptops.
Yeah.
So I like this old Razer laptop that I had. It was a nice laptop, but I was playing Doom Eternal on it all summer.
Yeah.
And after a while, it was so hot that the battery melted it.
Yeah.
It shouldn't have to be that way. The workstation should be able to take the beating. And that's what I've found, that the Fury and my Studio, even though it gets hot, the fans, I mean, they really cool the machine well.
Yeah.
So that, to me, is a defining facet of a laptop that's meant for work as opposed to just like a nice-looking one.
Yeah, in general, workstations, what differentiate them from just normal kind of PCs is the expectation that they're going to be running 24/7, right? So not just, hey, I'm going to game for a couple hours and I'm going to shut it off. But these devices are meant to be really workhorses. And the other is they're meant to be workhorses in an office environment. Right. So acoustics is really important.
Right.
And so really where we do, from a hardware perspective, a lot of our investment in testing is in the airflow through the devices. So how do I keep my GPU cool and not dump that air into my CPU and overheat everything? But also, how do I make sure it's doing that in a way that you're not hearing an air turbine in the background?
That's a great segue to workstations, because I have to say I was positively surprised when I ran the Z8 workstation, the biggest one, which can be extremely loud.
Yep.
But when it's idle, is whisper quiet.
Yeah.
That was very cool.
Yeah. It's really impressive what we can do within our labs and developing those type of things. And that's
but it's because there's like channels inside it. It's not like a PC like the one I have at home.
What's kind of missed, so we have our Z8 Fury on display here at the show in our glass case.
Yeah, it's in a glass case. You guys should go look at it.
If you haven't seen it, you'll see the 4 GPUs that are there. But what you kind of miss when you take the shroud off is how we are able to direct the airflow through that device, where each GPU is having its own unique airflow, and it's being directed and curved through the device so that you're not having any sort of temperature degradation across different GPUs or into the CPU, which is really important.
And it is like high pressure air. It's almost like a bike pump being like physically pressed over it.
Yeah.
Because that CPU needs that kind of cooling. What CPU is in that one?
In the one here?
Yeah.
I'm not sure exactly.
It's one of the new Xeons that you like. It's really hard to cool it.
Yeah.
Because it has 56 cores.
56 cores, that's
100,
right.
112 threads, I guess that makes it, right?
Yes, yep.
I could make use of that.
Yeah, good math, yep, absolutely.
Okay, so what else can you do with the workstations? What if you don't want to have them next to your desk?
Sure, so if you don't want them having next to your desk, which is becoming much more popular with remote solutions, some people say like, hey, I work at home, I don't have room for...
I can't have it next to my desk. It turns my room into a sauna after 15 minutes.
It's hot. It's loud. The workstations aren't that loud, but it can get loud. Or I just don't have the space. So we have some great new solutions. HP Anywhere is a solution that we're also featuring today, which is about being able to remotely connect into workstations. Whether that workstation's in an office, in a data center, in the cloud, wherever it is. HP Anywhere allows you to connect it to have like a in-person experience with this remote device. It's a great technology. It's a company we at HP acquired a couple years ago, Teradici, now it's branded as HP Anywhere.
Okay, so it lets you work on your machine, but you don't have to have it next to your desk.
Yeah.
What if you're doing something like CAD or something that requires a bit more precision? I know that remote desktop is not a super pleasant experience when you're using something that requires color accuracy, or you're looking at a 4K screen or something like that.
Absolutely, yeah, and that's the secret sauce with HP Anywhere, where the priority, it was built for people doing like media entertainment, where color accuracy was of the utmost importance. You couldn't have color drop, and so really, the color clarity is best in class, and then the way the technology works, the latency is super low. Right, so when you're turning a model, for instance, if you're doing a CAD, if you're working typically in remote environments, it will be very, let's say, non-smooth when you're rotating or looking at it. With the HP Anywhere solution, depending on your network activity, but in most cases, that's completely solved. It's a pretty incredible experience.
I have like I said, I have the studio laptop with a 120 hertz screen.
Yeah.
And so stuff is really smooth when you rotate it, and so when I'm doing visualizations, it's OpenGL accelerated, and it's nice and smooth on the screen. It's a pretty pleasant experience.
Yeah.
But I guess I just gave away that I use HP Anywhere because I don't have the Z8 next to my desk anymore, precisely because it's like a hair dryer.
Yep.
It just heats up the room. So now it's at the office. But where are things headed now? I got a bit of pushback from this one person that was saying, why would you have a workstation? We have the cloud. And I can't answer for everybody, but I can say for my own part that getting an instance in the cloud that's equivalent to the Z8 is basically impossible.
Yeah.
So I can't get that machine there. That's the first thing. I mean, I have Opteron disk in the machine with 20 gigabyte a second read speeds per stick. I mean, it just doesn't exist. But then the second thing is, in terms of the developer experience, I like developing here, developing in a container, pushing it to AKS on Azure. And I don't see these things as mutually exclusive.
No, absolutely.
What do you see at customers right now? Where are things headed?
Yeah, I mean, there's people out there who say like, hey, we do everything in the cloud. We don't want to do anything local. That may be what's best for you. It depends on your workflow. But more and more what we're seeing is that a lot of people like starting local. They want to iterate, they want to move fast, rapidly prototype with their model development. And then like you talked about, scale in the cloud. And that's really what the cloud's best made for, is scaling. But you're exactly right, there's a number of reasons why working local might be the best solution. It could be data regulations and requirements. I'm not allowed to use the cloud. It could be that, like you mentioned, I can't find the exact kind of performance like you would get out of Z8 in a cloud instance. Just because the cloud's there doesn't mean it has the right GPUs for what you're trying to do. But we view it very much as, hey, for some workflows, the right place might be your local. For many others, it's the cloud, and it's our job to enable the clear onboarding and enabling you to work wherever you want to work. The right compute at the right time. And that's really a guiding principle for us when we're developing new products and services.
Some customers have appreciated a lot that we've come with the machine and said, don't worry, we can fix a machine with GPUs on it, no matter what your sort of cloud setup is.
Yeah.
And when the work is done, you can rack mount the machine in your colo, setup, or wherever you have your local stuff. For government customers, that's been the case.
Yeah, absolutely. I mean, I think people don't appreciate too the fact that these devices are designed to be potentially be rack mounted, to be in a can be in a data center environment if you want to. So there is rackability, there is scalability within the machines. And then just from a kind of price per performance perspective, depending on what you're doing and how consistently you're doing it, could be a very effective option for you.
Yeah. So, I mean, one thing to consider when it comes to the price of these machines is that you write them off after 3 years.
Yeah.
So you have to take the price and divide it by 3.
Yeah.
That's the first step. When you're comparing to the cloud, or whether you're comparing to whether you should have 2 data scientists that are sort of mid-tier, or whether you should have 1 data scientist and then give them a Z8.
Yeah.
And what they can achieve with that. 1 expensive data scientist, and if you think it's expensive to hire a pro, wait till you hire 2 amateurs.
Yeah.
But just to whet the appetites of everybody here, we have about 2.5 minutes left. I want them to know how cool the top tier Z8 is, and I want people to know here, when it comes to the top tier Z8 or the ZBook Studio and these kinds of things, in terms of the budget of your IT department, these are a drop in the ocean of all the money that's being spent on random experiments. And if it can just inspire you a little bit, we've been talking about developer advocacy here for 2 days now, in terms that the developer experience is underestimated, the significance of it. So tell people, the top tier machine, what can they expect? What does it have in it? What is it?
Sure. For the Z8 Fury, I mean, like you mentioned earlier, it's got a Xeon core processor, 56 cores, pretty impressive, but really it's about the GPUs.
Mm-hmm.
We can, within a super single socket, we can support 4 NVIDIA A6000 ADA GPUs.
How much GPU memory is that?
Oh gosh, I don't even know. More
I think it's 160 gigs, right?
Yeah. Up to 2 terabytes of RAM. I mean, it's just
even more. 190 gigs of memory. Yeah.
So right. I mean,
2 TB of RAM, you said?
Yeah. So we're just we're joking over there. It's like, hey, we want to challenge people to try to max out the performance of this machine because it's going to be it's a beast.
I've had a chance to play on some of these machines, and it's not easy to do benchmarks that actually use everything.
Yeah. Absolutely.
You can run Prime 95 on it or something, but writing your own code that uses all the cores is not super easy.
Yeah. That is one of the big challenges is, we consider it a benchmark breaker.
Yeah.
Because a lot of the traditional benchmarks, you're used to running it takes 5-6 minutes.
Yeah.
This machine can run in seconds.
All right. I hope that whet your appetites. If you haven't seen the machine, go over and look on it. Talk to everybody at the booth. They're super helpful and friendly. If people are watching online, where should they go to check out Z stuff?
Yeah, so it's pretty easy. Go to HP Z Workstations, and you can find our whole lineup of ZBooks, the mobile workstations, and our desktop workstations.
Awesome. Cool. Thanks for the walkthrough. I hope you guys enjoy that. I'll be seeing you at the next session very shortly. Thanks for joining us.
Thank you.
Hey everyone, welcome back to another product demo session, expert session. I'm joined here by SqlDBM. Please introduce yourself.
Hey, I'm Serge Gershkovich. I'm Product Success Lead at SqlDBM, and we're an online database modeling and metadata management tool. So we're going to be looking at exactly what modeling is in the modern sense of the word, of the data stack, how it plays a role in decision making, and how it should be an integral tool of everyone's both business vernacular, business practice, and toolkit.
All right. Okay, let's hit it off.
Okay, let's do it. So before we get into the tool itself, I just wanted to talk about modeling in general and what it is. So when people traditionally think of modeling, they're thinking about these arcane diagrams, and they're thinking of a specific profile, typically data engineer or data architect. But modeling, again, as a model, is a simplification of something. So as a simplification, it really should be something that plays a role in making your life, your job easier. Planning, decision making, breaking things down, and then serving as a blueprint for later designs. So it's really something that most people, when they think of as technical, it's really something that starts with the business process itself. And what the business does, usually every business has a motto that drives kind of the company ethos, the company culture. Then that motto translates into their operations and what they do day to day. And what they do day to day generates data. And that data is that now when we're starting to get into the technical semantics, how do we store it? How do we serve it to our users? And more importantly, what questions do we ask of it? Because that's going to drive, those business questions are going to drive the actual design decisions of how we present that data, how we structure it, how we transform it, and then how we do analysis based on those transformations. And afterwards, there's also metadata, the data quality, the freshness, and logs that, again, are part of one larger data model, end to end. There's nowhere where you can stop and say, this isn't a data model or this isn't part of modeling. So this is where it actually happens.
Is this a chronological, or not a chronological, but a sort of dependent setup here, so that this part is dependent on the part before it, or can you approach this sort of at any stage of this hierarchy?
Yeah, I think initially there's straightforward. It kind of does happen top down. You can't analyze data of what you sold before you've sold anything. You can't sell anything before you decide you're in the business of selling. But once you start going, that's where I think you're referring to, like that. Then it becomes a loop of you generate business operations, those generate data collateral, that data collateral gets analyzed, decisions are made of, are we selling enough, are we not, do we need to reduce customer churn, decisions are made based on that, and then you reevaluate of, are those decisions having the right effect or impact that we intended, and that's where the loop kind of starts to get going, but it obviously has to start somewhere.
I don't want to hijack your presentation too much, but I think this is more profound than the listeners might realize, because this first step here, a lot of times is unspoken or implicit. And then when you do business as usual, you have processes and other things that have a lot of details in them, and like maybe they're supposed to model a business or a business model or like a vector, where you're headed.
Exactly.
But when it's not formalized, you can't capture all the things that are necessary to do the modeling that you're aiming to do. So this first conversation here, as a first step, is often skipped, and I think that leads to a lot of problems, right?
A little bit. So, like I said, a model is a simplification. So if you're heads down in a design decision, do we increase production? Do we increase the footprint of our factory? Is the answer yes or no? I don't know. You don't know.
Right.
What if I tell you that our business model, the logos of our company is to increase humanity's adoption of green resources? Do you know the company I'm talking about?
Not necessarily.
It's Tesla.
Okay, there we go.
So it's those kind of simplifications of, let's take a step back and say, what are we actually doing here? Is this going to increase our consumption of resources and adoption of green technology, or is it going to consume energy? So
that sounds like something measurable also, if just I might observe about that in particular. And we had a woman here sitting before from IKEA that was saying that their ethos is to provide affordable furniture. So there's a measurability in that kind of an ethos as well. Would you say measurability is necessary in order to formulate this first step then?
Yeah, it's knowing which questions to ask and then building the right metrics around those. Because again, how do you measure adoption? How do you measure your productivity or the impact you're having?
That's a valid exercise though.
Yeah, I mean, you have to kind of know where you're going, and then also how, the SMART, SAMRT methodology of tracking and making sure you're hitting those goals.
If you don't know what SMART metrics are, S-M-A-R-T, not like Homer, SMART. Yeah, if you don't know what SMART metrics are, look them up. It's a top-tier tool, I'd say.
Yeah.
All right.
So let's jump forward. Kind of building off of that previous slide, this would be the business process that you were saying. Does it happen in a top-down way? And this is kind of the simplification of, we start with the business and we start generating data. We can't do analysis on the operational platform, so we bring it into a data warehouse. Once we transform it, we're able to ask the right questions. We're able to draw some dashboards to bring those into context. And then those dashboards tell us up or down, make a decision, are we doing good or bad? But let's go take a step back and say, actually, we didn't understand the business model when we decided to build our data model on top of it. So simple things, are our customers up or down? Are we churning or are we gaining? We produced a very pretty dashboard and we said customer churn is up. Our executive knows what to do with that, so he's dedicating resources or money to a different department or to prevent other churns from happening. Because of a dashboard that was made that was visualizing some very pretty graphics, and those graphics are based on business formulas and models, based on data that's in the warehouse. But if we go all the way back, we didn't understand that, for example, a customer is someone who registers on a platform, not necessarily has to buy something, just register. So now we're reporting, when we built our actual operational data, we put the wrong formula in place, because it's not that there's a mistake, we just didn't understand the model. And everything else, it doesn't matter how well we build our dimensions, our facts, how clearly we then draw our visualizations, just the underlying assumptions are wrong. And this is something that's very easy to pin and visualize and detect before you add all this complexity of reporting and warehousing and ETL movement, just a simple diagram of a relationship and a cardinality of one-to-many, one-to-one, etc.
You get the impression from these discussions here that the main problem is type checking, that the date is formatted incorrectly or something like that. When people talk about data quality, but the data quality you're talking about happens at a much earlier stage.
Yeah, absolutely. Data quality, I think, is way downstream of, you've already got something in place, you've got a data model in place to load data into. So there's levels to it, obviously. So modeling generally starts with a conceptual model that's very simple to understand. It's just boxes and lines, entities and relationships. From conceptual, because it's so simple, a lot of times you don't even have attributes at a conceptual level. You can just validate, like what we just explained. Here's our definition of customer, and a customer, when they make an order, it can have multiple items. Is this correct, business domain expert? Please tell me. Because it's much easier to change a single line than it is to unload data, reload, change your assumptions, change your formulas. So this is how it's a process that builds on itself. So if you've validated the conceptual, we can move on to logical. And logical, we can now start capturing some of those attributes. Capturing, when I say that, I mean you and I having conversations, because as a data expert, as a data team, as the engineer, I don't know what necessarily are the business rules of my organization. The business know that better than anyone, the domain experts. And only through their help am I able to at least capture the underlying concept of what is an active customer. That way I can go off and build it. I've got my blueprint that we can call a logical diagram, and then I can go off and turn that into a physical implementation in a physical data model that's now database specific, that I can now work with and load data into before, again, mistakes that are made up here are 80% more expensive to fix than they are 20% earlier down the line. So this is what we're really driving at, of how do we do this and do it effectively. So I wanted to quickly just show what it looks like in SqlDBM and the approach that we took to modeling in general, which is we are an online database modeling tool, so it's all cloud native, cloud hosted. There's no infrastructure to maintain, no servers, no patches. If you have a browser and an internet connection, you can log in and work with your models. Because it's cloud-based, you can just add an email address of one of your colleagues and start collaborating instantly, nothing to install. And everything's hosted by us, different database types, different, all these versions that you're seeing here, these are version controls of the models themselves, completely hosted, and also makes it very easy for us to integrate with other cloud-native data platforms like Databricks, Snowflake, Google BigQuery is coming next month. We're really excited about that one. And in fact, if I start a project from scratch, so we also do support on-premise databases, so all we really need is the DDL, so whether you do that via Direct Connect or you upload a file, it's just the metadata that we're interested in. It's very lightweight. But let's say if I was going with Snowflake, because it's cloud to cloud, I can just quickly connect to Data Warehouse. All I need is my server and username. Whoops. I don't know why my this thing is coming. It's not letting me type for some reason. Yeah. For some reason, my keyboard's gone crazy.
Okay.
Technical difficulties aside, let's just skip this step. My mouse still works, so let's just look at an existing project. Let's go back to the dashboard, hopefully.
Did you switch to Dvorak? I use Dvorak sometimes when I do that.
I hope not.
It really messes with things.
I think it's either something stuck on my keyboard or something's interfering. If I'm using a Dvorak keyboard, then there's no.
That is odd. That doesn't look
lost.
like it should bring up a browser. So it seems like there's something with the browser.
Let me disconnect. Maybe it's the HDMI. No. Okay.
What if you try another browser? Does that work?
Let's see. No, it's my keyboard. I can't type. It's not the browser. Let's go with Edge.
Oh man, I've done so many demos where things have screwed up.
Well, exactly. I mean, it has to screw up on a demo, otherwise it wouldn't be a demo.
It wouldn't.
Okay, I think we might be.
All right, we're getting there, guys. Can we plug in the HDMI again?
Sure.
It's fine.
Okay, I think we're back in business.
Back in business. All right, sweet.
All right, so logged into Snowflake, finally. This should have been the easiest part of the demo, but here we are. These are the data warehouses in my account. I can take a look and explore my schema. So we're just going to do a quick demo, spin up something existing that we can look at. And we're connecting to an actual data warehouse and getting the DDL. We're going to just spin up a couple of diagrams to have something to show. Once we hit upload, we parse those objects into things that the project recognizes, hit import. Let's also do an auto layout.
This is a setup that has been created outside of SqlDBM, right? So you're just looking like from a schema perspective from the outside. So somebody can be managing this Snowflake setup completely independently of what you're doing right now.
Yeah.
Okay.
Yeah, absolutely. So what we've just created in a few clicks is the visual ER model of our
Oh my God!
database.
I wish this. I asked for this stuff.
As
They're
an
like,
engineer,
we might have it in a drawer somewhere on a piece of paper that somebody a diagram that somebody printed millions of years ago. I hope this is what I think it is.
It is what you think it
description.
is. Yes, it is what you think it is. And what I'm bringing in has a lot of the due diligence already in place. So these constraints, these are physical constraints from the database. That means somebody has done their homework and actually defined how these things relate to each other. If that was not the case, we can still infer these just based on some very simple naming conventions of include, what do my keys include? Key, ID, PK, etc.
Right.
Do I want to exclude name, date, amount? So I can generate these on the fly, detect where these exist, create these virtual relationships, and get up and running, even if my data architect was sleeping at the wheel and didn't declare these for me. And the important thing now is what I was saying earlier, of having a clear representation of what it is that our business represents. So here, presumably this is a warehouse, so it's taking data from the operational system. So all of these things are, again, we're talking top down. But the idea behind doing this thing in the cloud and natively in a browser is to make it accessible. So you're an engineer, I'm an engineer, we understand these types of diagrams. But even as an engineer, you might want to scale down the complexity, just for example, explore relationships, ignore attributes, or show this to our business users in something that they can understand, which is just boxes, lines, descriptions, and without having to really convert anything. I'm still looking at the same physical database, same physical tables, so I can click in and edit these descriptions. I can see the underlying columns. I can go all the way as abstract to in table mode if I wanted to, and still see underlying columns and attributes. So if I was working top down, if I was just working kind of a whiteboarding an idea, I can, as we were saying earlier, start easy, just start with the entities, talk to you about the relationships that they share or don't share, and work my way up. So this, we're just...
And I'm thinking, because there are some tools that are a little bit similar to this, not bundled with the databases, certainly, but that some databases have tools that go with them that can do this kind of stuff. What is the advantage of using SqlDBM here? The thing that pops in my mind now, obviously, is that you can apply it to all the databases. So that's nice. You don't have to have one tool per database. What other things are nice about SqlDBM compared to some of these simpler tools that others have used to make like UML diagrams and that kind of stuff?
Yeah, great question. It's really, like we said in the beginning, we are a database modeling and metadata management tool. So as you said, you might be working in a larger type of organization that has different databases, different data teams, data domains, so you can have unlimited projects and unlimited data diagrams of the different database you're working with, letting users access them all from one place. But let me jump into a project that's been a little bit more...
Does that mean if I have one conceptual setup that makes use of a SQL server and an Oracle server, that I can, with this, combine them into one diagram that shows the conceptual relations across them?
Yeah, you can do that. I mean, our projects are database specific, so you can have a generic project that you can use as your logical base, and then you can convert that to Oracle or to Snowflake and generate them, because obviously there are going to be some differences when you physically implement them. But yeah, you can do it that way, and a lot of our customers do. So especially if you're dealing with like a data mesh type of scenario, or if you're an IT services company that has kind of a blueprint that you like to roll out to different customers, you can convert that to any database type and then just start tweaking the little fine details. So in this project, this is the same data model. It's just been a little bit more advanced. So this version number up here, every time we make a change to our project and we save, we generate a revision. So we have now version control. We have the ability to roll back.
Wow, that's nice.
Compare, and
is that something you do in the tool, or does it?
Yeah.
Okay, so you versioned this setup, and somebody changes something in the database. They add a column, or they change maybe a type and then rewrite the column or whatever. How is that reflected here? What happens?
What happens is you would be able to first, let's go ahead and compare revisions just so you see what it looks like. So right now I'm on almost version 900, so any two revisions could be compared. So the last time I was in here, I added a column, I created a table from scratch, I deleted these other tables, and this is just for me as information. So I can go and see who actually did it, which developer, was this part of a release, we can flag these things.
Would you want to tie your analytical code to versions of the schema?
Absolutely.
So you can say my SQL query is designed to work with Sprint v896 or something like that?
Yeah, because all of these things happen hand in hand. So transformational is the fourth type of modeling that happens after you've got logical, conceptual, logical, physical. Then you start writing your queries. So I can't query a column that doesn't exist. So you obviously want to keep everything in sync, and once you start doing these transformations and creating like an aggregation, let's say, you also want to bring that back into your overall picture of now you have a transformation creating another table, but you want to bring that table back and say there's actually a relationship here. It might not be a constraint type of relational relationship. It's a transformational relationship based on logic, based on business questions.
Yeah.
So all of these things that we're kind of driving towards is, and just save this project, is like what you were saying. We can visually see that something changed. We saw what changed. We can now generate an alter script of those changes, so we can bring that into our database. So we have alters, creates, drops, anything that happened between any two revisions, or database. So right now we're comparing to the history of the project itself, but we can also compare to a live environment or even environment to environment on the fly and generate those alters. And I kind of want to jump into...
Well, there is one thing I would wish for, but I think it might be too much. I don't know if, well, you guys probably can't do this, but it would be cool. And that would be if somebody is editing a table, that it would say that there is a conflict, and it wouldn't let you make that edit because you see here that there's a dependency on a certain column, and so you would first have to do a revision in the metadata management saying this change is coming and so on, and so that they can make the change in the table so that you don't break things by mistake by changing tables. And
that would be great. You'd kind of want to, I think we'll get there eventually. It's not something that we can do overnight, you're right, but that's kind of what we're aiming for. And just to finish up, I wanted to also make sure that, like you said, we're including these visualizations, we're including people in here that would generally not be included in the data modeling workflow, meaning the analysts, the engineers, that usually they're not the ones making the changes. They just want to come in here and find the data assets they're looking for. So there's a documentation screen where people can, for example, I'm looking for a Salesforce ID. I don't know which table it's in. I don't know the column it's called. It might have been renamed to customer ID. So from a single screen, we can search across object names, column names, even down to the description level, and say, okay, somebody, maybe one of our business analysts has come in here and said, this is...
Is this only in SqlDBM, or this comes from the outside, or this is part of SqlDBM metadata management?
No, this is not metadata. So this is, we just happen to be seeing it all in one place, but this is going to get re-injected right back into the database as DDL.
So it goes from SqlDBM back into the database. That's pretty cool.
Yeah, exactly.
I love the idea that there's not an additional sort of data pool that starts building up that you need to manage, that this is just like a shim around what you already have, but makes it accessible to different people.
Exactly. So we don't want to be a bottleneck. We want to, if it makes the access easier all from one place for someone that may be not as familiar with SQL and querying even metadata in a database, they can search it from here. Otherwise, it shouldn't just be kept here. It goes right back so that other BI tools can leverage all of this metadata, inform the queries based on the constraints, things like that, propose queries.
What's the easiest way for people to get started if they want to try it out themselves? I think it's good for people to give it a try. I sort of itching a little bit to try it on some scenarios myself.
Sure.
How should they get started?
Very simple. Go to SqlDBM.com, go to our website, and you can actually get started right from there. You can do a free trial, and it's an online tool, so there's nothing to install. You can just hit go and start playing with it.
With your own databases?
Yeah.
So it's not, so it's not even just a demo account. You can actually trial it on your own databases.
Yeah, exactly.
That's sweet.
That's the idea. So you can get a feel for the UI if you want a full trial of all the features, all the bells and whistles. Also from the website, just click Contact Sales. They'll set you up with also a free 2-week trial of all the functionality, so you can involve your broader team and get to know the tool. So yeah, unfortunately, we can't see everything in a single demo, so we encourage people to come check us out. And it's not just the relational stuff that we're doing. We're also expanding into column lineage, some of the logic, helping the same way we kind of break down visually how tables relate to one another and entities relate to one another. You can take a view, for example, and also understand the inputs and outputs, and I
have to say, legitimately, based on just the parts you've shown me, and I imagine there's more behind it, this is one of the more compelling tools that I've seen. A lot of the tools here are all sort of good, but this actually seems very useful immediately. So I appreciate the demo, and I hope this has piqued your interest. It seems easy to get started with. Go give it a try, and thanks for being with us today. There's only so much you can show in 20 minutes, but this was pretty cool.
Yeah, it's been a pleasure. Thanks so much.
Thanks, and we'll see you soon on the main stage. Thanks, everybody, for joining. Have a good day. Welcome back to the main stage. This is the main stage, isn't it? Where all the magic happens. We've had a number of really sweet sessions. I feel like there's been a couple of themes that have been cropping up over and over here. We have the one we just mentioned a second ago, developer experience. We have technical debt. I don't know if I've been pushing it too hard myself or not, but it seems like it's been cropping up in the discussions that we've been having here. There's been more of a focus on figuring out what the true essence of value is rather than these technobabble words. I don't want to say that data mesh is a technobabble word, but I mean, thing is, these tools are phenomenal right now. This last tool we saw here with SqlDBM is something I've been wanting for a long time. So we have tools to be able to get started. And I know we say this every year, you know, the tech is already here, you can get started, but the essence of the discussions we've been having here are more entrepreneurial in nature than they've ever been. It's quite evident, and I think it's because the palpability of tools like ChatGPT and stuff have made CEOs and C-level and shareholders aware of the business potential of AI that AI leaders have been talking about all this time before. So now we're seeing AI leaders have the direct ear of the CEO and having to manage expectations. What's reasonable to expect and what's not. And you know, for all these outrage posts on LinkedIn and newspapers about whether AI is too awesome, not awesome enough, or whatnot, now it's our job to set the expectations. What can be done in the short term and what can't be done. So if we go back to the points that we've discovered today, developer experience. This is something that I'm going to circle back on forever personally, but if you think it's expensive to hire a pro, just wait till you hire 2 or plus amateurs. It's worth investing in an environment where your star developers can do the best work that they can do, so give them the right tools. The second one is when it comes to technical debt, is if you focus on the value early enough, then the technical debt will take care of itself. We talked about some complex scenarios here where you have legacy systems that created value at one point but don't create value now, and you have new systems that are creating value that are dependent on these old systems, and you're still paying to maintain these old systems. But it's not that they're not valuable anymore. It's just that the dependency has been shifted to newer systems that are further down the line, and so you need these tools in order to do not data lineage, but cost lineage. So there are tools in place in order to be able to do that, to follow the conceptual lineage of the value that you're creating. What else did we talk about? We had developer experience, we had debt, we had the language models, right? Everybody here was pretty much in agreement that this is not just a hype thing that's going to come and sort of come and go. I'm not sure if we're going to be talking about language models at next year's Data Innovation Summit, because much in the same way that we don't talk about the internet anymore, it's going to become embedded in certain business practices. So, you know, now when people are talking about social media, they are actually talking about the internet. It's just being social on the internet. Now we have a word for it. So I think we're going to be talking about large language models for a long time. It's just that people are going to be entrepreneurial and creative enough and find applications for it, where we're going to have new areas of business and domains and application for large language models that are going to become really standard, and they're going to become really standard really fast, because with the help of the cloud and all the tools that we're seeing, scaling out these technologies is not the problem. The bottleneck here is the creativity and the ability of people to get together to be able to sort of converge on, you know, the essence of the value that your company provides to the customers, what the vision of the company is, and all these kinds of things. So really, it's about people getting together, agreeing on what they want to do, and disseminating that sentiment to the organizations. So you play a large role in that. You're the evangelist in your company. I wish you the best of luck in the coming year, and I will be seeing you at NDSML, Nordic Data Science and Machine Learning Summit, and at Data Innovation Summit 2024. I know there's a sign over here that you can buy tickets to next year's event. This year's event was popping, over 3,000 delegates. Next year's event might be even bigger. I've been hearing rumors of 4,000, 5,000 people. It's actually a hard time just getting in people through the door and finding venues that can accommodate this many people. But everybody I've been speaking to here has said that day one especially was just, the energy was huge. And I hope we can carry all that energy into the projects that we're involved in. Best of luck. Like I said, this is the main stage, and I'm going to go ahead and cut it right here. See you in the ether. Over and out.